Okay, so I've never done a live stream before, but I guess we'll see. The um, the subject of this is so Chamath had posted this challenge a couple days ago, where at June 7th, so today, 10 a.m. Pacific, which is in 6 minutes, he's going to drop instructions, and then we'll have exactly 8 hours to build and submit a solution designed to be hard. Um, and so this is something. So I said, well, I replied to this. I said, maybe I'll give a live stream. I think the odds of me being top are basically zero because there are a lot of kids that are younger and smarter. But I thought as a as an exercise, I think it would be fun, and also to show it, I think it might be kind of interesting. So I don't know. Obviously, I don't know what the challenge is, but we will give it a shot. I've been doing some experimentation with cursor and trying to I don't want to say vibe code because to me, vibe code is kind of the irresponsible version where you just, uh, yeah, you really just close your eyes and let Jesus drive, and then you get whatever you get. But AI accelerated coding, where it's like, okay, yes, I could implement this, but man, it's kind of annoying. So let me have the AI generate it, and then I'll review it for quality. Maybe write some testing routines to or have AI generate testing routines to validate it. And so you end up with something that's not terrible quality. Um, so I think, the terminology wise, vibe coding has kind of shifted from the original, um, you know, you just don't even look at the code to now any AI. Anyway, that's uh, more a matter of English usage. Um, so let's see. So 5 minutes. So so I mean, I guess I could take this time to introduce myself. So, I've been coding for so I've been working as a software developer since 1998, so I'm old. And most of that time I've been doing pretty much all that time I've been doing primarily algorithm, scientific, mathematical types of stuff, which is image processing or scientific, uh, instrument calibration or that type of thing. It's we've had some MATLAB, some C++, some embedded implementation and C and C++ for image processing. So that's historically been my pattern or my what I've been doing professionally. I'm also interested in um, things more broadly, like other weird languages or um, more recently I've been doing some Python um, and like web stuff, for instance, is like I mean way back I tinkered a little bit with PHP and some JavaScript, like raw JavaScript, way back, but a lot of the modern frameworks like React and whatever the Next.js things kids are using these days is not something I have a lot of experience with, but I have built a couple things, just kind of toy projects with using Cursor as a helper. So I just kind of use it as I see people ask about languages and whatever. It's like, well, languages don't matter anymore. Um, but kind of the experience of how programs go together that still does matter. Um, so mostly just let's see what else can I tell you about. Um, so this also says that there's a 10K cash prize and a job offer. So job offer, I'm not really interested. That's not really the point. And plus, I already know that I'm not going to be not going to be winning this thing. So but I think it well. So anyway, so there is something else. I mean, I guess I'd take this opportunity to talk about, and that is in building a program. There's an important distinction between writing the code and understanding deeply the customer problem. So if you look at, someone builds a, clone of Minecraft, for instance, in, an afternoon, it's like, well, yes, you can get the implementation of a block-based world and so forth, but if you look at like, Minecraft wiki, there's like, 1,000 pages and all the little creatures and all the little behaviors and how the redstone, properties work and how you can build a this delay block or the sensor block allows implementation of these things. And so if you were to look at a full specification of everything that Minecraft is, it's super deep as far as all the little behaviors and how, and so that's something that is that the AI won't make for you. Well, I mean, I guess it could, but it might not be any good. And so the implementation is separate from the deep specification. And then there's also the marketing aspect. Even if you had a clone of Minecraft, it wouldn't necessarily make a lot of money. So that there's some of the non-technical issues are, I think, deeper than people deeper than people realize. So as it is now, or as it has been, you have the deep specification of the requirements or deep understanding of the customer need and the implementation. And there's kind of both major pieces. As the implementation goes away, now the understanding of the customer problem is much stronger, or can come to dominate. And then you have, maybe the product managers then become the leaders when it comes to or even more so, um, unencumbered by the implementation difficulties. Anyway, that's kind of a more philosophical thing. All right, so it is 10 o'clock Pacific. Let's see what we do. We have a begins now. Okay, GitHub link. Mission: complete coding challenge in 8 hours. Submissions are accepted until 6 p.m. Pacific today. Okay, so 8 hours. Okay, black box. All right. Top coder challenge: black box legacy reimbursement system. Reverse engineer a 6-year-old travel reimbursement system using only historical data and employee interviews. Acme Corp's legacy reimbursement system has been running for 60 years. No one knows how it works, but it's still used daily. 8090 has built them a new system, but Acme Corp is confused by the difference in the results. Your mission is to figure out the original business logic so we can explain why ours is different and better. Okay, um, I'm gonna post a how do I get the URL of my live stream? Lower than okay. Hang on. I want to um, uh, view your channel. Yeah. How do I get the link? Okay, here we go. Share. Okay, video link. All right, so I'm gonna go back here. Well, reply. See what people. Okay, how many? I don't expect to have any viewers. Learn more. Okay, okay, okay. Uh, Create a perfect replica of the legacy system by reverse engineering its behavior from 1,000 historical input output samples and employee interviews. Okay, the trip takes 3 inputs. Trip duration days, miles traveled, total receipts amount, single numeric reimbursement amount, public case. Okay, so there are some rules. Okay, so there are some rules baked into if you travel for 3 days, but it's not over a weekend, and the number of miles traveled is less than 25, then the rate is this, or all this kind of stuff. It's interesting that's, well, I mean, I said the dates, but this is actually only spends the number of days. So, okay, analyze the data to understand patterns, create implementation, implement your calculation logic, run.sh. Must take exactly 3 parameters. sh. Uh, I do have WSL, so I can make a run in under 5 seconds per test case, work without external dependencies. So this is almost like a um, what is it? The um, advent of code or something. It's very well contained. I was expecting something that might be um, a little more complicated, like okay, go build a DocuSign clone or something like that. But this is actually uh, okay. So I'm going to output a single number, PRD, to understand the number of days spent traveling. Interesting. So it has objective success criteria. Known or suspected bugs in the legacy system must be preserved in the output. So it's possible. Uh, I wonder if the legacy system has changed over time, because that's something that can happen. In which case, you get into a sort of neurosis, or you could. Um, Answers for this: 1,000 historical. Okay, all right. We'll see. All right, let's do it. Um, okay. All right, so I guess we'll do a clone first. Da, 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 da. All right, code. Well, these are just JSON. I mean, this is kind of just like grab the files. Okay. Uh, all right, let's set up cursor. Yeah, like I said, I don't expect to win. I'm, just gonna do my thing and not really worry too much about new open folder. I'm gonna make a new folder. I'm gonna say Chamath. Okay, folder, and then I guess I could clone into, oh no, okay, let's see. I'm just gonna unzip these stupid files. Okay. Uh, Get the public set, yeah, go for it. Um, shit, I should have done that first. Anyway, let me get my downloads. All right, some projects, Chamath. I'll go ahead and make this a Git repository anyway, even though, all right, okay, and then update. Oh shit, somebody reposted. I don't even know how this works. Oh, Chanta. Okay. Uh, I should probably have not done that in public, but anyway. Let's see. Okay. All right. Plus commit. Okay. Now we got cursor. I'm going to say uh, readme. Okay. Add this to the context. I'm thinking a Python program is the simplest way to implement the requirements specified in readme.md. Do you think this is a good approach, or is there some other language or framework that would be better? This is fun. Like I said, I've never done a live stream before, so this will be interesting. Can I see how many people are 100 concurrent viewers? Jesus. All right. Okay. Python, alternative bash. Write the whole thing in awk. Oh boy. JavaScript. Yeah. Yeah. Okay. So we'll start a Python. Okay. Da, da, da. Okay. Uh, run.sh.template. Echo to do input. Do I have bash? Yeah, I do have bash. Um, how do I start a bash? I'm gonna embarrass myself. How do I start a bash? Can I start a bash? How do I, fuck. Okay. Uh, calculate example one Python implementation. Yeah. Okay. Well, no, I'm just gonna. I can do that. I can do that later once I get. It's. I think this problem is not an 8-hour problem, so I think I'll have time to solve the bash stuff at the end. So I'm just gonna work. I'm just gonna do a Python. Um, so I'm gonna say make a new file. Okay. Create a Python file, calculate underscore reimbursement.py. That will be our main implementation, and it will take 3 command line parameters. The first being trip duration days, the second being miles traveled, and the third being total receipts amount. And I guess, should it print the output on the console? Oh, echo. There you go. Output should be a single number. So I guess next step. Oh, Jesus. Um, calculate reimbursement.py. New file. Okay. All right. All right. Okay. So now if I do, where am I? What? Did I spell it wrong? Calculate reimbursement.py. Calculate. Okay. 0. Okay. Um, okay. Reimbursement 0. Okay. Implement business logic here. Okay. Interviews.prd. I guess, we'd use Anaconda, not Python. Anaconda is Python, right? Uh, uh, all right, generate results. Private cases, evaluating test data, results generated successfully. Let me see if there's more guidance on the, okay. Complete submission form. Let me look at what this looks like. First, last name, get a repo, what was your score, eval.sh, Twitter. Okay. Okay, that's straightforward enough. Private cases, public cases. So wait a minute. Oh, I see. Public cases has the outputs, private cases does not. Eval. Okay, let me bash. So I'll do does it invoke run.sh? Yeah. Okay, so I'll change run.sh. We'll do Python. Okay. So now if I do feels dumb. I feel dumb. I should know. Oh, you're kidding me. Okay. No such file or what the calcu shit. Rename calculate reimbursement. All right. There. Okay. So now run works. So now eval eval JQ is required but not installed. Okay, so let's try WSL. Users, vector, desktop. Yeah, well, Bash is this part, but Python will be the implementation. Bash is how the testers are launched and stuff. So if I do run page, Uh, do I have bash? Am I running bash? sh. Shit. Okay, okay. All right. I give up. I give up. I give up. All right. I'm running WSL and I can't seem to get bash to work. Is it installed by default? Bash not found. What the fuck? Okay. Are you kidding me? What the? Is there a? Okay. Jesus Christ. Okay, so I should have anticipated this. Okay, so what is JQ? Uh, JQ to you know what? I got Docker. It's been a minute, but I got Docker. Let me stop these guys. Okay, let me. No, I should be able to do a WSL. I know. I don't want to do Docker. Well, if I have to, I'll do Docker. But okay. Uh, in WSL, I don't have bash. What is wrong? Is this just a configuration issue? It kills me to not correct spelling errors, but npm ijq. Okay, do I have npm? WSL-L-V. Oh, maybe I'm running out. I have multiple distributions in. Um, okay. Oops. Yeah, so I'm not running Ubuntu. I'm running some minimal Docker version, I think. So let me stop, shut down Docker. No. WSL. How do I get a list of distributions? WSL.s. What's the name of the standard Ubuntu distribution? Something called Ubuntu. WSL-I-install Ubuntu. There we go. All right, so this will take a minute. You can use bin sh instead of bash. Yeah, the so binsh works, but what doesn't work is this JQ something that was the error message I was getting. JQ is required but not installed, and I think I guess maybe it's npm or some kind of thing, but the WSL distribution that I'm having is Jamie. Um, the distribution I have is just crippled. It's not even close to complete for all the. Oh, see, now I got colors and everything. Okay, I got bash, and now if I go to um, users vector test, now I should be able to do h123 Python. Oh, okay, Python on the okay. Let's install Python. Let's probably just apt get Python. Apt update install Python 3. Okay, so go back here, change this back to Python 3. Okay, so that's working. So now the next eval.sh should maybe work, or I'll find the next thing that's broken. Okay. Yep. I'm missing JQ. Okay, should enough. All right. JQ version. All right. Now, I'll see you later, Chamath. Okay, kind of slow. Extracting test data. Nice. Okay. Oh, crash. Okay. Okay, evaluation complete. Accuracy 0. That's about what we expect. Your score. Keep analyzing the patterns. High error cases. Interesting. Errors encountered. Oh. Oh, so some of them, no. Well, okay, I gotta look into this. Line 13, mild traveled. Invalid literal for int with base 10. Okay, so that shouldn't be an int. Trip duration days. Well, maybe days should be an int, but the well, so it'll be maybe it should be an int, but we'll parse it as a float. Okay. A little bit surprised that the evaluation is slow. 1,000 is not a lot of not a lot of Um, 1,000 is not a big number. So I could ask it to have cursor convert the evaluator in from Bash into Python and then just run it that way. I'm not sure if that's okay. So I didn't get any crashes this time. Um, okay, let's see. Um, okay, I'm going to convert the. Let's see. I'm going to convert the JSON into a CSV file so I can view it in a more kind of a more interesting sort of a or a more have better visibility into the relationship between the values. So I will create a new Python convert to CSV. Okay, and I'm going to add public cases to the cursor chat. Um, I have a file, a JSON file containing a bunch of data, and effectively there are four pieces of information for each record. There's trip duration days, there's mile traveled, there's total receipts amount, and there's expected output. And what I want is a Python program that will ingest the JSON file, which is a list of records, and I wanted to output a CSV file with four columns, and the column headings should be the four field names from the JSON. And that's all that that's all that the program should do. So this is cursor. Um, this is cursor. So it uses Claude 3.7 on the back end, I think. It sort of automatically chooses. You can also override, oh, Claude 4 Sonnet. Oh, interesting. Anyway, so it, I guess, automatically picks. I haven't done a deep dive into how to optimize the model selection. Okay, Python. So I'll do convert to CSV. Okay, so it will uh, add a main routine that accepts a input JSON file name on the command line and an output CSV file name on the command line. And Windows has a feature that's, you do Windows key H and it has a built-in speech to text, which I find nicer. My typing is not uh, not as fast as speaking. Put it that way. All right, let's see what we main routine. Oh, I see. So it was a script. Now it's a main. Wait, what was it? What was it? Rewriting the convert to CSV. No, no, no. There's that whole if main. Update the convert to CSV.py instead of creating a new file to do the main routine to do the conversion. I guess it's already got sysargb here and stuff, so um, I guess maybe should have phrased it differently, but There we go. Yeah, it's kind of more of a refactor and less of a okay. Let's accept all. Um, Change it so the main function accepts inputs, uh, file names. Um, this is, I'm getting a little too OCD here, but change the main routine so it accepts parameters specifying the input JSON and the output CSV. I'm converting it to a CSV so that I can load it in Excel and then do plots like scatter plots of average um, average days versus reimbursement and all those kinds of things, because then those patterns will jump out. So um, that's the reason. But for the processing, yeah, everything's going to be JSON records. All right. And now let me try convert. Connect. Public cases dot JSON. Public cases dot CSV. Convert. Okay. I'm getting this. Something done. Okay. Field name. Oh, it's expecting the public cases dot JSON. This is what each record looks like. So update the conversion accordingly. In particular, the ingest. Don't need this right now. Run to SH. Don't need this right now. Okay. So it's doing input data record input writer right row. No. Uh, um, the expected output is not within the input data. Oh, no, no, no. Okay, so it is getting record, pulling out input data. Okay, yeah, yeah. Okay, very good. So let's try it. Okay, public cases.csv. All right, where's Chamath? Public cases.csv. That looks about right. Why is this not? Why is this not showing in Excel? Okay, open. This PC. I should probably not be showing everybody my stuff, but oops. CSV. Okay, trip duration. Okay, let's just do it. Simple scatter. Okay, if I add, ooh, trend line, roughly approximately $61 per day. Um, okay, and then if I were to plot miles traveled versus, oops, miles traveled, huh, okay, maybe 57 cents a mile. Uh, and then if I do receipts, um, okay, so this is probably going to be 1-to-1, roughly, you would think. 50 cents, 50 cents, maybe, uh, re, uh, maybe 44%, 44% reimbursement. Okay, this is like the dumbest possible policy that's kind of loosely similar to the data. What if I deduct uh, uh, non-receipt reimbursement? Okay, so I'm going to do minus. Okay, so this is total reimbursement, not including um, receipts. And this is 2,997. That's very suspiciously close to a round number. So this is for miles, right? So maybe 30 cents per mile. So what if I were to deduct at 30 per mile, non-receipts minus 0.3 times miles. Okay, now days. Uh, Still big variance. Big variance. Um, Now we're talking $35 per day. Wait a minute. Oh, because they're not independent. The longer days will have more miles traveled. No, it's not that different, or not that. Okay, what about days versus receipts? Interesting. They're uniformly okay, but this could be a test set that's generated and not realistic in that sense, where it's just uh, implement a policy, feed a bunch of random data in order to generate these public cases, I think, because it'd be very weird if there were not some relationship here. Yeah. So on average, the receipts are $25 per day. No way. No way. Okay. Maximum 14 days. Interesting. Okay. Um, hmm. So what was I looking at? Non-receipts and miles traveled. Of course, it might not be linear. Well, but that would show up here if it were. no, it would. Well, if it were nonlinear, it would show up. Um, 'Cause if I do miles versus the raw, wait a minute. Reimbursement goes up and then it flattens off. So if I do, okay, so this is sort of like, so let's see, 1,000. Let me look at, so I'm going to sort by sort by uh, receipts, expected output or receipts. I'm going to sort by receipts. Okay. And then I'm going to look at uh, receipts less than about, well, I'll cut it short a little bit, so it'll be like 1,100. Okay, so insert a, okay, now I'll do fit. Okay, 88% reimbursement. No, but that includes, okay. Anyway, and then I'm going to do a fit of the 1,500 and higher, and I think it'll be basically 0. So you get no reimbursement above 1,500. Negative 0.04. Okay, so it looks like there's a cutoff on receipts. Looks like there's a cutoff on receipts. So if I look at the low receipts and then I correlate non-receipt versus miles. So I'm gonna do it. I'm gonna copy everything below. I'll say 1,200. Now I can do non-receipt reimbursement against miles. So how's non-receipt reimbursement so negative? Someone's got some, unless it contains mistakes. Okay, where's the negative? Negative 105. 1 mile, 140 miles, receipts of 255. So maybe there's also a cap on, yeah, this could be a multi-dimensional negative 123 is also 1 day. Negative 18 is 2 days. Or it could be a per day cap. Okay. Okay, expected output. So can I throw the data to Claude to give you trends or insights? Yeah, I guess. I guess I could try that. Try or Grok maybe. Oops. Load a file. Cases .csv. What patterns do you see here? In particular, expected output should be dependent on the other columns. Claude has more analysis cap. I don't know if I have, let's see, topic, uh, uh, shit. All right. Allow use of third, okay. Correlations don't have direct access to run computations. Trip duration days. It's just guessing. Hypothesized patterns. Yeah, but it's just guessing. Okay, yeah, do that. What the hell? I'll, all right, let's see. I should probably not. I should probably hide that. Okay. Okay, come on. Claude. Oh, come on. Claude 4. Okay. Upload a file. Public cases. Looking for relationships in this data. In particular, expected output should be a function of the other columns in the data. Can you do some analysis and tell me what the relationships are? So I guess Claude can do better React. Huh. Okay, gonna make a line chart, make a chart, I guess. Calculate correlation. Interactive artifact, that's kind of interesting. Test a linear combination. Yeah. I guess I could do a Duration correlation, miles correlation, receipts correlation. Trip duration is a dominant factor. Okay. Okay, so what if I were to take cloud reimbursement, what would the linear relationship be? What are the coefficients? It might have been here, but I'm just not seeing it. Because this is like an R value or something. Yeah, so this is kind of the same thing I was doing in Excel. Oops. Are you kidding me? Okay. So I'd said what? $61 per trip. I just look at this relationship. $61 per day, 44%. So let me just do 61 times reimbursement equals 61 times trip duration days plus 30 cents per mile plus 0.44 times total receipts amount. All right, now previous evaluation, oh, that was bash. No, not that bash. WSL bash. Previous was 13, so initial 0 function had score of 135.0111. 35.011. All right, now we'll eval again. I wonder if it makes sense to, I guess, what makes sense? If I had a, do I have PyTorch? I don't have Py. If I, anyway, from this possible linear function, days plus 0 times miles has score of 25436. Okay, so it's 135,000 to 25,000. So I'm like 5 times better. Okay. So I want to do a search. Um, I want to do a search for, um, I wonder if I can, let me do time. Can I do a timing? I'm really surprised this runs so slow. Um, Basically same inputs, 100% output difference. Cases 9 and 10. Oops, I already sorted these. Um, but I haven't saved it. Let me, 9 and 10. Yeah, well, I'm thinking like in the real world, stuff can have mistakes. So maybe there's a typo, and so you're scored. So you have to like recognize, oh, whoops, that was a mistake, and or not that you would have to recognize that, but in the data, you can't expect everything to be perfect. That would be my interpretation of these two results being so close uh, and so different. Um, Because yeah, if it's like if you encounter a problem where the input data is not perfect and you throw up your hands and say, "Whoops, I can't solve it," that's not acceptable. So I'm guessing, right, that this is so, and a better, well, better in some sense solution might not minimize like R squared. You might not minimize mean squared error, for instance, but the correct policy might be the one that has a small number of outliers that are somewhat larger because it's like a like a Ransack algorithm, for instance, doesn't try to minimize mean squared error on all the points. It's like, well, try to find a kind of coherent subset uh, that has a uh, that has a policy that fits. Anyway, that's my opinion on that. Oh fuck, I haven't even read the interviews. Uh, well, whether it runs, oh, does it run on three inputs? I mean, the data, only three inputs are available, but I guess I should read interviews in the requirements document. Is this okay? Acme Corp relies on decades-old internal system to calculate travel reimbursements for employees. Built over 60 years ago, the system is still used daily despite the fact that no one fully understands how it works. The original engineers are long gone, their source code is inaccessible, and there are no formal documentation of the system's logic. Sounds uh, uh, although the system continues to operate, stakeholders observe frequent anomalies, unpredictable reimbursement amounts, inconsistent treatment of receipts, and odd behaviors tied to specific trip lengths or distances. Interesting. Attempts to document or decode the logic have failed, and different departments now hold conflicting folklore about how the system might work. So this could be a function of, okay, uh, there's a bug where um, if the values are um, it's rounded to the nearest tenth, and then something happens, or I don't know. Um, uh, System relied on. Replacing is risky, but can depend on unmaintainable. Black box is even riskier. 1890s built a new system, but Mac Corp is confused by the differences in results. Your your mission is to figure out the original business logic so we can explain why ours is different and better. Oh, so it's not just figuring out the policy, but also figuring out the bugs is maybe what I'm getting from this. Um, So that's sort of that makes it a lot more interesting. See the numeric reimbursement amount with no breakdown or explanation. There's widespread belief that the result is influenced by a mix of per diem rules, mileage adjustments, receipt totals, possibly other unknown factors, meaning bugs. Uh, it's also suspected that there are one or two certain calculations from past modifications. These may produce results that appear illogical, but they are part of the current output and must be preserved in the replica. I guess you would preserve it in the So anyway, project goal. Primary goal is to recreate the behavior of the legacy reimbursement system, including any known or unknown bugs that may affect output. By replicating the current behavior exactly, warts and all, Acme can transition to a modern, maintainable code base with confidence. Once this baseline is established, business stakeholders will be in a position to propose rule changes or improvements based on solid understanding. Product description. You'll build a replacement reimbursement engine, accepts the same input parameters, trip duration, so only 3 inputs, produces the same output, matches the system's behavior across a wide variety of scenarios, including edge cases and likely bugs. So we have to replicate the bugs. You will receive 1,000 historical examples, a set of informal discovery interviews, okay, uh, inconsistent anecdotal contradictory memories on how a system behaves, in further rules, and recreate the output producing logic. Okay, high fidelity, must handle all 1,000 test cases with minimal or zero deviation. This is interesting. This is a really interesting problem. The fact that we're challenged to reproduce the bugs given only the output is a really interesting um, case. Really makes it an interesting problem. Okay. Oh my God. Okay. Uh, what are the top level policies for reimbursement according to these interviews? In other words, per diem rates or reimbursement for expenses or daily rates or any of that type of stuff. I don't want to get into the edge cases or bugs right now, but I just want to get a picture of the overall intent at a high level of a simplified policy. Per diem rules, around 100 per day. Mileage at a standard rate for longer trips per mile rate drops after a certain threshold. Intent is to fairly compensate for driving, but not to incentivize excessive mileage. Receipts for actual expenses. There's a cap or diminishing returns on. Sorry, let me catch up a second. I don't think it runs on 3 inputs. Yeah. Start simple. Yeah. So I think start simple. Look at the um, so my current thinking is start simple, catch, 80% of the cases, maybe match exactly. If it's $100 per day for some subset of the, or whatever, a simple policy might describe a majority of the results, but then there are edge cases and bugs. Like if you're like there's a policy that has a cutover at 5 days. Let's say there's a cutover at 5 days. Well, maybe uh, days 1 through 4 and days 6 through 14 are treated differently, and there's something weird happening on 5 because somebody implemented less than or equal to 5 instead of less than 5, and now there's some bug in there. And so getting a policy that covers the majority of the data, and then those cases, the error cases, kind of float to the surface, and then those can be used to hunt down the bugs. Maybe, I don't know. That's kind of my thought um, for how I'm going about this. Hidden magic numbers. Yeah, absolutely. Yeah, it might not even be exploitation, but just kind of um, bugs and fixes. Yeah. Claude Max smashing this. You solve the simple ones first, then tackle the complex after. Yeah, that's kind of what I'm. Um, uh, Medium high expense totals tend to get the best reimbursement rates. Medium high expense totals, very low receipts may be penalized. There's a sweet spot for trip duration, where reimbursements are most favorable. 5-day trips often get a small bonus on the per diem. This might be a system appears to reward efficiency. Covering more ground can lead to bonuses, but only within a certain range. There's a certain optimal miles per day ratio. Per diem for standard travel, reimburse mileage at a stay. But I calculated, okay, I'll put, um, okay, so if I look at the minimum, uh, it sort of looks like there's like even odd thing here. Anyway, I guess weekends are also maybe present, but not in the, um, okay. 522 divided by 6 is, um, well, let's see. So how am I going to, how am I going to do this? Um, how am I going to do this? Uh, okay. So the minimum is 126 for the first day, 203 for the second day, 303, 322 for the fourth day, 406. So it seems like each day, so 522, 482. I'm wondering if the minimum could be, um, no. I'm 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 thinking of the factors as independent, and I'm sure they're not. So, um, hmm, how is this going to? Okay, let me sample some of these regional. Are these staff accountant, marketing manager, business partner, procurement analyst? Uh, Unpredictable, Cleveland, Detroit. 2 weeks later, almost identical trip. Similar expenses. Got 623. Same receipt total, same everything. Looks at the calendar. Okay. I mean, I guess there's a, well, are there hidden variables that That seems, so what I'm thinking, are there hidden variables like calendar or weekend days where when you submit the report, the, a Wednesday to a Wednesday or a Monday to a Friday or, includes the weekend or not. And I'm thinking the way the problem is phrased, if that were available, like in the real world, if that were available, you would include those as inputs. And instead of three input variables, you would have more than three. And so I'm thinking that there's going to be some superstition around those, maybe about where he's talking about calendar. But in fact, the system does take three inputs, and in principle, it is possible. I mean, there are bugs and so forth. So, um, but in principle, it's possible to um, that the system produces these inconsistent outputs without depending on weekends and without depending on that. So I'm going to treat the problem as if there are no hidden variables like calendar days and so forth. Because if it, yeah, again, if it were, then part of the, it would be part of the PRD, for instance. Um, yeah, employees use a legacy interface to submit these three things. So I'm going to treat it as if there's no other hidden variables. Mm, it's about effort. No, 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 no. Okay, so this effort, this guy is guessing. Short drives, you get the standard rate, no surprises. But longer drives, it's like the system gets confused or something. So short drives, no surprises. So I think there is a short drive. So maybe there's a short drive rate. Um, so I'm going to sort by miles traveled. Sort A to Z. Okay, miles traveled. Um, well, maybe. Hmm. So no surprises, even though there's variance, which means, so let me just do a cutoff at 100 miles. Delete. Okay, so for short drives, now if I look at receipts versus, okay, this looks like this looks very linear. So if I subtract, was 12, 12, 1269 over 1632, 77 cents per, 77%. Okay, so if I look at um, output minus 0.77 receipts, 72. Okay, now if I look at miles versus uh, that's that's there's no relationship there at all. Okay, what about days versus? Okay, so there's a bit of a, maybe the days versus miles is going to be correlated or not correlated. Hmm. Yeah, it definitely looks like there's penalties going on here. But miles, it's like you don't get paid anything for the first 100 miles. But I thought over here I was seeing, where was it? Oh no, I sorted by, no, I sorted by miles and I cut the bottom. Okay, but it looks like when he's saying consistent short drives, standard rate, no surprises. So it looks like short drives, you get nothing. Oh, 600. So 600 is considered a, okay, receipts, higher receipts, higher reimbursement period makes sense, right? Wrong, I had 2,000 expenses. Okay, definitely buggy in the expenses. Uh, yeah, well, this is the thing. If something's inconsistent, then people develop superstition around it. Magic number theory. Certain receipt totals always get good. 847. Efficiency bonus theory. Yeah, okay. Okay. Makes sense of the numbers. Staff accountant. Okay. Yes. Mostly there is. $100 a day seems to be the base, but then there are these weird adjustments nobody can explain. $100 a day. Okay, so if I go days versus, if I look at trips 7 days and less, okay, so let me sort on days and cut at 7 days. I'll just take this part. Okay. Where am I? Okay. Check. Trips under up to 7 days. Okay. Now, if I look at days versus output, okay. So it's 117 for the first day. It's at least, yeah, but it starts to get funky. 482 for 7 days. So if I say minus $100 for the first days, okay. Anyway, let me say about output minus 100 per day. Okay. Now I have, this is going to be, and then damn it. Plus 50 every third day. divided by 3. I'm going to do a floor, no, ceiling, uh, so that's going to be 111,222 minus 1 times 50. Okay. 50 penalty per every third with 3-day penalty, that plus that minus. Okay, now I'll put okay, so I've kind of corrected the per diem. Is it 50 minus 27? Is it 75? Per 50, 75. Okay. So now if I look at 3-day penalty times ooh, that's interesting. Wow. Wow. Okay. And then if I do 1,000, interesting. That's super interesting. Okay. What about output receipts? Ooh, look at that. Okay. Yeah. So now let me now okay. Receipts 1243, 1124. So it's basically linear up to 1200, which is what I was sort of hypothesizing before. So capped receipts, if receipts is less than 1200, then, or I can just do max or min. Receipts are 1200. With capped receipt. Okay. Now let's see what the 3-day penalty looks like with this. Okay, I guess we're kind of, okay, now we look at days versus, sorry, miles. 35 cents a mile, which I was, what was I guessing? What was I guessing? 30 cents per mile. So let's say the nominal rate is 35 cents per mile. Okay. With mileage. So this is basically a residual error. that we're calculating. Why is this got a um, mileage? Now I'm at a negative 200. That's not really good. With mileage, oh, but it's like mileage, you have to exceed a certain amount to qualify for mileage, looks like. With mileage, uh, 35 cents per mile, it's like you start negative, it's like you start, so the actual relationship, um, actual mileage, I'm actually paying less. So imagine you pay 35 cents a mile and you subtract $211. 35 cents per mile, uh, minus 200, or subtract 211, max 0. Okay. Now it's 18 cents a mile. So instead of 35 cents a mile, maybe it's 35 plus 18 is 40, 53. 53 cents a mile minus, okay, we're not, um, mileage rate, 0.3, 0.5. No, it's actually, okay, capped receipts, mileage rate. What do I do? 3-day capped receipts. With capped receipts, with mileage. Okay. Square error. Mileage rate, mileage minimum. Minus, shoot, mileage, mileage offset. Okay. Okay. Solver. Where's my solver? Solver. Solver. Going to minimize. By changing. Okay. So 33 cents a mile, $1,000 receipt cap. Okay, this is still pretty bad. But let me go ahead and implement this guy. So I'm saying um, oh, and I don't know how this is going to apply to the beyond 7 days, but anyway, well, um, mileage, duration. Okay, I mean, we're still not close at all, but anyway. Per diem. I guess I could optimize over the per diem rate also. No, I'm not going to bother with that. Okay. Per diem equals 100 times trip duration days. No. Receipts per diem off, minus 75 trip duration days divided by 3. No, is this an integer? No, I mean, it's going to be a float in general. So I'm going to say divided by 8, divided by 3, ceiling minus 1 times 75. Okay, 75. Okay, ceiling. Per diem total, per diem minus per diem offset. Okay. Plus, no, it's minus 30 every 30 days. Minus 75 every 30 days. Hold on. Okay, so I'm accounting for it by subtracting. I'm subtracting credits and I'm adding penalties in order to, yeah, in order to do the prediction. Okay, capped, uh, capped expenses, capped receipts, min total receipts amount, or 1200 is actually 1081. It's a weird number, but okay. And then mileage, mileage min, mileage rate 30. I'm doing what, 33. Mileage offset 127. Mileage total equals rate times mile charge times mile offset, minimum, maximum 0. Okay. Per diem total, mileage total, capped receipts. Okay. Second attempt based on first 7 days. This is probably going to be worse, actually, but I guess we'll find out. Seems impossible. Yeah. Floating point bug. 104 score. Sure. Okay. You say so. 19. Hey, lower. It's 19, 263. All right. All right. Calculate reimbursement. Keep my old stupid ones. 1, 2. All right. Okay. So how does this? I mean, I guess the to get a really low score would require, well, so I'm thinking back to this ransack style algorithm where, let's say, there are some outliers, inliers and outliers, and the inliers are described by some policy that's formula. Obviously, it's not a, you know, are described by some formula, and if you can figure out that formula and predict exactly some subset, then that would be nice, and there would be some kind of, branch. I guess it's if you have a bunch of, let's say, bugs or a bunch of special edge cases, whatever, and they're all overlapping, you could end up with almost zero instances described by the mainline, pure formula. I'm just wondering if there's uh, what else have we got? Because this looks pretty random. Well, not random, but it's not where a majority of them are described by a solid line and then a few of them are outliers. It's like all of them have some amount of contribution from some aspects that are not being calculated. So so and I feel like I'm in a situation where I'm manually thinking of features like this every third day aspect, for instance, thinking of a feature, uh, implement it, solve, optimize around it or something. But that's not going to uh, scale well for all the possible bugs that could be present. I wonder if it makes sense to. It's also possible I could overfit on the uh, public cases if it's like, oh, looks, so, some kind of, uh, and so now with a coarse mathematical description like this, then I think the odds of overfitting are low. But if I were to get, oh, when the mileage ends in a nine and the total receipts is greater than $1,000, I might get a large pile of special cases that doesn't generalize to the private cases, in which case it would make sense to separate out a training. So if I'm going to do automatic feature generation, for instance, then it would make sense to separate out a training set and a test set so that I don't fool myself into thinking that I've got it solved when in fact I've just overfit to the public cases. Um, Best score so far is 7,400. Okay. I wonder what, I'm reluctant to look, but maybe I'll take a look, see what people are saying. Um, oh, I have it. Oh, I have it. Oh, do I? I already have it open over here. What are people saying? As if there's two more models at play. Okay. Let's go. Let's go. This is fun. Bonus points. This is an ad for Cloud Code. Rules to resolve ties. Oh, wait. Am I still on the post? Not a coder. Okay. Actual versus predicted. Oh, that's interesting. Still a long way to go. 8 and 173 make no sense. I wonder if if I could, anyway, I wonder if there's a way 8 and what? 8 and 173. Uh, where's my 8 and okay, so this is my looking at 1 day short mileage. You get more, yeah, 255.99. You expense less, you get more. Yeah, I mean that. So there's bugs. I mean, big deal. I mean, big deal, but I mean it's a um, yeah, it's not supposed to make. I mean, not sense. I guess is what I'm trying to say. Okay. Yeah. Okay. ChatGPT suggested what in 30 seconds exactly? A linear, uh, yeah, capped profits. I mean, capped, yeah, per diem with offset and all this kind of stuff. Yeah. So I guess what I'm saying is, uh, doing these features manually is the kind of sucks, and it's probably not going to get a good to save records to avoid overfitting. Well, yeah, okay. Yeah, okay. Uh, Fair enough, I guess. Um, okay. So what I'm trying to think is how I can not be generating all the features by hand and letting it try stuff. Uh, or if there's a way I can accelerate trying features like, what if, yeah, anyway, so I don't know. Um, hmm, okay. Um, so if we treat this as, so let's see, maybe, I'm wondering if I should, hmm, I'm just wondering about what other perspectives I can use to visualize it because if, like, let's say there's a rounding bug or then there would be a visualization that would highlight that. But I mean, I can crunch on it all day, but without, um, but then all the candidate features that I can think of are going to be extra time wasted to implement this kind of stuff. Hmm. Score of 8,600 with this, yeah. What am I at? Yeah, so I'm still not at all good. Um, mhm. I wonder if I could do this in a three-dimensional view somehow, if there's a relationship between duration and miles and receipts and error or some kind of a, because I mean, it's possible with, mileage versus error and receipts versus error and days versus error um, individually don't have a pattern that jumps out, but in conjunction could have some could have some patterns. Um, so I guess, is there a way to do it? Can I do a 3D plot in Excel? Uh, okay. Well, let me look at rounding issues. Insert. I mean, I'm just going to do until I get some kind of insight as to how to do um, features automatically. I don't. Uh, I guess I don't. Anyway, receipts fraction. Odd, okay, what's our residual relative to? Um, okay, there we go. No, x, y. I'm going to put this over here, even though it's okay. Fraction of part of the receipts relative to the best estimate, or the residual error, basically. Okay. .49 and .99 are special cases. So let me filter out. Okay, so .49 and .99 are special. So let me do. I want to retain. Should I? Do I need to retain the order? Okay, I'm going to delete these guys. What was I doing? Non-receipt. Okay, so I'm going to. I'll just make a copy. Really filtered. All right, so I find those with receipts. I'm at receipts fraction. Okay. Maybe I should put those after the. No, instead of doing that, I'm going to make a column receipts fraction. Insert buggy fraction equals. Okay, now I can do filter. What? False. Is this some? Is this some? I don't get it. I don't get it. Okay. If damn it. Yep. Times 100. I'll say round. Equals 49. Okay, got it. I don't know what. Does OR not work? Okay, so that works. Okay. So now if I filter, plots change. Okay, interesting. Okay. All right. Um, that's not that much help. I mean, it's a factor. Yeah, I'm just doing the visualization, trying to. That's it. That's Excel. That's why I'm doing Excel. Lowest score gets joined startup, I guess. There's also a 10K prize. Yeah, it's on X. Uh, okay. Right. So I guess let me look at the true cases. Maybe I can decrease my score a little bit, even though it's buggy. Uh, well, no. Well, uh, crap, what am I trying to do? Score right now is 19,000, 19,263. So not very good. Um, so it looks like there's a penalty. I mean, I guess I could take the average penalty for 0.49 and 0.99. I'd say if it's 0.49 or 0.99, then deduct $400. Or yeah, because this is my oh no, this is my error. So let me find a oh is that and that's the 9 and 10. Yeah, it pays lower. Now the amount lower is kind of random between $1,000 and but if I were to say deduct a couple $100, my score would get better. So let me see what happens. If round off error equals, let me do uh, total receipts amount that round minus times 100 round um, round off error round yeah okay if round equals shit okay receipts fractional equals floor uh, total. Okay, here's the fractional part. Math receipts fraction. If receipts fraction times 100 round equals 49 or equals 99, then uh, round off penalty equals 200. So I penalize you if you are just by constant. Obviously, it's not constant, but the score should anyway go lower. I would hope. It's been a while since I've updated the score. Including round off penalty is 0 error. Okay, cool. Well, I already knew that I was not going to come close, so guess and check the way to go. Yeah, probably not. Yeah, well, who knows? Damn, this is slow. Holy shit. I guess this. Why is this? Is this unreachable? Ah, fuck. Okay, cancel, cancel. All right. Reimbursement too. Shit. A lot of duplicate trips with the same exact miles travels. Oh, specific trips with a rule for trip duration. That's an interesting idea. That's a good idea. Isolate one variable. Am I lower? 18,772. Yay. Oops. Um, that's a really good idea. Isolating that. Okay, back to this guy. Let me look at um, with the same. I wonder if it. I wonder if. Oh, okay. Miles traveled. Let me do it. Instagram. Eh, okay. Let me sort and then plot. Insert. Uh, hmm. Those are pretty uniform, but there's a big spike at the end. Also, some are fractions. 1061.15, is that actually? Is that a bug? I mean, my transfer, did my conversion mess up? 1061? Didn't I just have? Wait, all these are fractional. Oh, these are integers. Okay, so it looks like early on. Okay, so this has been reordered. Let me. Um, I'm going to save this as an Excel. Public cases edit. Let me go back to the original and look at this integers, fractional integers. Interesting. Okay. Is there a time over trend? That's interesting. Okay. Hmm. Hmm. Miles fractional equals at minus 4 1. Okay, so between here and here, get random. I wonder if those have a different rule. Could be, probably does. But let me look at miles sorted. Um, okay, okay. So there aren't, except for at the end, miles. Okay, so the last one jumps by like 100. That's that little tick up at the end. Okay, but I could look at differences between, okay, sorry, that's probably what you meant is duplicate values. So I wonder if duplicate values and duplicate, okay, um, durations. So if I look at, um, so let me, so first let me toss these out because these might have other things going on, okay? And I'm also going to toss out 0.49 bug if I do uh, my no receipts minus floor receipts equals 0.49. It's got to be a fractional. This has got to be a fractional. Sorry, a floating point. Freaking okay. 100 times round equals 49. Okay, some true. There we go. Some true. Okay. Now we will sort based on z true z to a. Right. So I'm going to yank out all these rows, and then I'm going to say 99. I'm going to sort true. I'm going to yank out these rows. So I'm culling out rows that I'm suspicious of. Then miles traveled versus trip duration. Okay, I'm going to sort by miles traveled. And I'm going to say equal miles duplicate. So this is if that minus that equals 0. 0. Okay, duplicate or not, and then I'm going to Okay. Miles and duration. Say miles and duration duplicate. If that times that equals. Okay, miles and duration duplicate. So this is a duplicate, this is a duplicate, and then I can I guess create data. So I'm going to pull this data out. Okay. Okay, so I'm going to make a, okay, this is equal to duration, traveled, receipts 1, expected 1, receipts 2, expected 2. Receipts 1, okay, duration, traveled, receipts, expected payout 1, receipts 2, payout 2. Okay, and then this is, so this can be defined on every row except the first one. And then I can screen based on this guy. So I'll sort filter equal to 1. All right, so now this is, does this work? Yeah. Okay, miles sorted, I don't need anymore. Okay, so now I can look at, for example, delta payout versus delta receipts. Equals, okay, this should be kind of linear, or so you get 35 cents on the dollar for your, which what did we solve for? 44 cents on receipts. Receipts. Oh, so this was 1-to-1 on receipts, but okay, anyway. So some of them are higher. Oh, leaderboard. I'm scared to look. I knew I was going to get my ass kicked. Uh, leaderboard is up. Don't overfit the public data. Oh yeah, no shit. Okay. Leaderboard. Fifth place is 16,000. I have 18,000. All right. Oh, so these are people that have submitted. Okay. Well, I guess if I ran out of time and I had to submit what I have now, I would, and who knows, maybe I wouldn't get 18. Oh, wait a minute. But these scores, uh, oh, I guess to win you have to get 0. But the score is calculated as, is a score an average or a total? Average error, 186.72. 25,000. Um, eval score. Average error times 100 plus the number of wrong cases times 0.1. So if you have a larger data set with the same average performance, you get a higher, worse score. Okay, so the scores are not directly comparable, but 1,000. Oh, but that's only like 100. So if I have 1,000 test cases, um, that's only contributes 100 to the score. So it's relatively, it'll stop you from getting a 0, but it won't get you, but the scores are otherwise sort of comparable. Okay, all right. Okay, I should, all right, so what we were looking at, okay, so now let's look at same duration, same travel. What if, so I'm looking to see if the longer or further travel has a tighter relationship or a looser relationship. Um, just kind of eyeballing it. Maybe maybe these data points are hmm, do absolute value of delta because this is kind of symmetrical. Not kind of, it should be symmetrical. Yeah, let me look at the ratio to, um, well, no. Um, well, the polarity also matters. If the okay, so absolute, that's not good. Um, So like this case is a negative delta, but a positive change in the payout. So negative 25.56. Let me look at that one. So here, receipts are 25.56. Let me look at this guy. Receipts are higher, payout is lower. Okay, so anywhere where these have the opposite polarity is, I guess I could swap them if can I do uh, sine of that? Okay. So negative 30. So these are high payouts. Let's see if combine. It'd be nice if it were a three-dimensional plot. Sine. No. Okay. Let me just do scatter plot of these two. Okay. Could I color code? Holy crap, look at this. Huge. Let me double check that I've got. Let me double check that I've got this. Okay. So here's one duplicate. 12. Wait a minute. What the? Ah, fuck. Okay, hold on. Okay, sorry. I'm getting too confused here. This is true when both are duplicates. So 1259, 1259. 1259, 858, 1377, 2247, 1629. Okay, so this does capture the both records. I guess technically I should sort. Well, okay. How do I do it? fuck. Okay. I don't know why I would type that. Anyway, like I said, this is the first time I've ever done a live stream. Um, so anyway, we'll see. Okay. Um, I'm just trying to. So the symmetry of these guys would mean. Okay. I wonder if I need to. Uh, I don't. I don't really know what happens next. Hmm. Looks like there might be two subsets here that fall along these. So I'm looking at these at this line. Um, I'm looking at this line. It's kind of like a line right there, and there's kind of like a line right there, and maybe that's a. Uh, so I guess it would be. Okay, but it's a delta versus a delta. Yeah, but that means there's a. No, no. Delta payout versus delta receipts. It's like there's. It's making my brain hurt. So here's payout versus receipts. Payout two versus receipts. Oh. Oh, okay. So if damn, I was not thinking about that. Okay. So I have receipts one, I have payout one. I have if I do capped receipts. Okay, these are delta receipts doesn't make sense if each one is capped. Okay, so capped receipts. This is min of let's say I say cap value 1200 something is min of receipts one or cap value. Okay. Cap receipts two minimum of that guy. Okay. Now if I do capped receipts versus payout. Oh, payout versus capped receipts. Okay. Delta capped receipts delta payout. Okay. Now if I look at the pattern between those two. Ooh. Okay, so sometimes there's a delta payout, even though both are capped. Okay. Oh, 80 cents per. Okay, that doesn't make sense. 80 cents on the dollar for, see now this has a little step in it, so I think this is not right. Mm, I don't know what I'm doing. If I, what? How come that one does? I don't know how that got messed up. Let's see. Receipts versus payout. So now when I predict um, capped receipts versus payout, it's like the payout is capped. Um, well, it's almost like I want to look at all payouts over, because the payout is combined miles and um, duration and receipts and everything. So it's almost like there's a cap. So not just let me look at receipts versus payout on the overall. Okay, so receipts are definitely, so maybe I could look at high receipts, because that is no. I'm trying to think. If you have for example, if you take days and receipts, combine it and cap it, and then add miles, you're going to get a certain thing. Or if it's miles and days, calculate it, cap it, then add receipts, it's going to be a different thing. Or so so I'm thinking uh, receipts, duration versus receipts. I mean, I'm kind of going back to the beginning, but okay. The receipts versus payout is much tighter relatively. So this band is only like 1/3 of the maximum, whereas this band is like already 3/4 of the total. So there's going to be um, so not sure what that means. Uh, duration versus payout. Okay, miles versus payout. Miles versus payout. So it's sort of like, it's almost like miles is uncapped in the sense that this still keeps going up a little bit. So it's like miles are added afterward. It's like maybe there's cap on receipts, then it adds duration. There's a cap on that, and then it adds miles, because it looks like, anyway, it's sort of, kind of sort of looks like that. Um, if I look at if I look at high receipts, and then I look at miles versus look at high receipts and long durations. Well, durations might not be duration. If I look at high receipts and a single duration, like take, I don't know if there's a histogram, if these are uniform or what. Oh, that's interesting. But let me do format axis, bin width. Okay, 1, 2. Count if this equals equals okay. Paragraph. Okay, it should be basically the same as this. No, it's not. 1 to 2. Number of bins, 14. Okay, there we go. So that kind of matches up. So if we take, so I want high, so let's say I take 12 days, because there's kind of a lot of them, and they're a little bit tighter. That's interesting. There's more of them, but they're tighter. Okay, let's say I take 12 days, high receipts, and then I can look at the relationship with, um, let me write some of this down. Maybe there's some caps and intermediate caps, like for example, why does it keep saying 1081? Like for example, cap on receipts, and then cap on per diem plus receipts, and then cap on receipts, and then add per diem and cap, and then add miles, just as an example. So if there's kind of stages of caps and stuff. The plots seem to show that mileage might not have a cap, but per diem definitely does, and no, not per diem, but receipts definitely does, and per diem is maybe capped. Okay. Okay, so I will segment out 12-day trips and high receipts. Could have and then analyze high receipts, and then analyze mileage. Okay. Okay, so I'm going to sort on miles. I'm going to sort, where's my, okay, I'm going to take this guy. This is the original data. What's this? So this is cleaned with the like 0.49 stuff yanked out. We're going to sort on miles. No, sort on duration. Delete everything except for 12 days. And then high receipts. So sort on receipts. Look at receipts versus, okay, sort on receipts. This guy looks like a weirdo, so I will start at receipts of 1526 and higher. Um, and then let's see what miles versus payout looks like. Okay, this is 21 cents a mile. 21 cents a mile. Look at these guys. Let me look at, okay, let me say prediction equals 0.2114 times miles plus 1643. There. Okay. Let me see what this looks like. Okay, big error. That's this guy, right? 601. I wonder, receipts. I wonder if there's still like a round off or a integer something. Let's look at let's see, fractional equals receipt minus floor receipt. Uh, Probably not, well, I don't know. I'm going to reserve judgment. Fractional receipt. Not seeing a, no, I don't see anything there. Uh, uh, I'm just wondering if there's like, add up all the digits or some kind of stupid thing. 18, let me look at, maybe the lowest and the highest are the, interesting. 18, 528, these are so different, but they're so similar. They'll end in 8. All these negative, well, okay, I'm going to say mod 10. Mod 10. Mod. But they're going to stack on top of each other. No, not really. Okay. Okay. Um, that is that real or is that fake? There's nothing up in this quadrant. Is that statistically significant? Overfitting? Maybe there's a, that would be a weird bug to have, but I can't even say if it's a weird bug to have. That seems like, well, the thing is, this is not a physical system, so I can't go back to the physics as to what's expected or not expected. Damn. Oh shit, I'm running out of ideas here. Maybe 5. There's a lot of 5-day trips, which sort of makes sense. Should I look at, would 5-day trips instead of 12-day trips be, I mean, I'm seeing 21 cents a mile, but the deviation is still super huge. If you assume that it's, or maybe the cap is not really a cap, or if the cap is, so I'm looking at this, receipts versus payout. If, like, let's say there were a cap, but like the low digits of the receipts leak into the payouts, and some of this variation is still a consequence of. I'm just guessing. I have no idea. So a function of receipts, even though it doesn't track linearly, even though it's not doesn't trend with receipts. Short trips. Yeah, miles. The thing is, miles and well, miles and receipts are weirdly uncorrelated. There's kind of a cluster down here. I don't know if that's just a um, I don't know if that's just um, a random. That's yeah, I don't know if that's real. So miles and receipts, and then duration and receipts is also bizarrely uncorrelated. So this is like someone used a random number generator to generate these in order to uh, in in a realistic scenario. I have a hard time believing that. So this looks synthetic to me. And then miles versus duration. Yeah. So I guess the other thing is if there's a chronological trend and um, okay, this is receipts. This is mile. Oh, I already sorted. Ah, damn, I already sorted these. Is this one? Shoot, I don't. Um, shoot, I sorted them. uh, uh, public cases too. All right, let me go back and open the original data. So the payouts. So it's entirely possible that the rules changed and that the early ones different rules. Okay. So it's a little weird that it's a little weird as far as I'm thinking about realism, and uh, maybe that's not the right way to think of it. But if you have a realistic, um, so the lack of a correlation between receipts and da- receipts and miles, receipts and days, and miles and receipts, the lack of correlation makes it look unrealistic to me, like they've generated synthetic data instead of. Um, but then the chronological pattern, chronological pattern does look realistic, or they've simulated a realistic. You know, they've injected some simulated simulating a change in patterns. Um, so that's kind of interesting. Insert miles, duration, payout, oh, receipts. Oops, receipts. So there's some short trips here, and all the trips were long. The expected payout, the payout still behaves weird until these don't quite line up. Um, no line, but we'll add a marker. No line, but anyway, no line, but add a marker. Okay, so receipts, I can't really see. Okay, so maybe in addition, I need to uh, treat the early and the late ones differently, because I don't think it's just a matter of, I mean, they're still correlated, but okay, let me insert. Okay, row number. Okay, so what if? Okay, so when does it settle down, so to speak? Insert. Sort of becomes random around 152. This one, 153. Okay, 152, 153 is sort of where 156. Okay, so if we truncate, I wonder if I were to truncate the public cases. What if I truncate public cases? Um, so let's see. Uh, if I truncate it, yeah, see, 987676712. So let me say let's say 150, so 12, 247641. Okay, so if I truncate these, I'm just saying out of curiosity, what would the score be? Is it much better, much worse, very different, or basically exactly the same? So there's only 50, so I'm going to expect a slightly lower because of that 0.1 times the number of wrong cases, but we'll see. Let's put Gemini into a loop of sorries. Okay, 19,518. So that's worse. It's worse. Okay, so so what does that mean? That means the early what does that mean? Okay. Hmm. I'm looking at on X, this guy's saying there's as if there are two models. So he's got some kind of model. I saw something. I don't. It's probably not the same thing that he was looking at, but when I mean, here if you kind of squint, maybe there's no. Actually, no. I'm supposed to. I don't know. It's when I was looking here. Yeah, maybe there's a kind of a thing here. Maybe there's kind of a thing here, but this is not. Anyway, that's okay. So it's not the case that well, I have coefficients that I fit on the entire data set, and they don't, when I truncate the data to only the last 80%, the overall fit is slightly worse, not significantly. But it could be that it's still true that the beginning and end have a different characteristic. So what that means is, um, okay, I'll do public cases early, and then I'll do public cases uh, later 80%. Okay, so I'm going to take starting from 152 about. So here, 7676 7612 4. Take these. Um, okay, now if I do just something like this. All right, this looks the same as it did before. This looks like this guy's odd. Is that one of the .99 ones? 49, yeah. Okay. And these are going to be all the .49 and .99. .99. Just yell at Claude. Okay. Here's a bunch with the same exact. Oh, what date is this? Duration. This is receipts. Um, so there are not that many. Okay, so those look the same. Let me look at miles versus payout. This is an interesting gap here. Miles versus payout. There's not a gap, but I'm gonna put these on the same. these into here. Nope. Oh, yeah. No. Yeah. Okay. That worked. Weird. Marker. Too big. Automatic. Built-in. Okay. So the early and the late are not that. So the blue dots are the early first portion, and the orange dots are the later. And I don't see a huge. Yeah, those are shaped kind of, basically the same. Payout versus receipt. Do this for the later, the later data. If I overlay this onto here, okay. Marker, way too big. It still looks like a cap around. Okay, so this is going to be 0.49. So it looks like the bug applied early on also. It's almost like a ratio instead of an offset. It's like everything is divided by 2 or 3 or something. Instead of a constant, round off 0.33 reimbursement times. Although it's actually 0.49 are the ones that are big and 0.99 are not. So let me just do 0.499. This is probably overfitting. But anyway. Okay, let me look at the interviews some more. What did I get here? 18,581. Okay, interviews. Let's go back to these. Things that look like patterns per diem. Everyone assumes there's a standard daily rate, but mostly there is. $100 a day seems to be the base, but then there are weird adjustments nobody can explain. 5-day trips almost always get a bonus. 4-day trips, 6-day trips, normal rates. 5 days always a little extra. Is that true? I don't think so. So in my first, so I'm calculating the residual. So this is my prediction versus days, and it's pretty similar without any special rule for 5 days. Although this is short trips, less than 7 days. So it's almost like 7 days get a bonus. So I think, except last week I saw a 5-day trip that didn't get the bonus. Mileage is definitely tiered, but mileage is not. No, mileage is not tiered. You'd expect that if this were tiered, you'd expect some kind of curvature to it. Yeah. people are, these people are, it's not a simple drop. I tried to map it out, some kind of curve, high mileage trips. Receipt processing. It gets really weird. Definitely a cap. It's not a hard cap. It's not proportional. A lot of ground in short time. It's not just miles divided by days. Rounding things definitely intentional, though. Well, probably. Oh, receipts ended 49 or 99 cents. You often get a little extra money. No. It's consistent. Consistently different, I guess. Okay, regional marketing manager. Lisa from accounting says it's some kind of curve. Well, yeah, we'll see. It's an experiment. I've never done it. Never done a live stream before, so who knows? Maybe this will be the future for interviewing because like how do you game this? It's like I don't know. Or how do you fake it? You're not going to have a bring all your open book test. Bring everything you know how to do and see how well you do. One trip I spent 600. Kevin says you had 1,200, almost for reimbursement. Submission being tied to lunar cycles. Okay. 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 Jen from HR. HR. Basically, everyone says that they don't know. Looks like the employees lower reimbursement. Yeah, I mean, people are getting all kinds of theories. Small receipts thing is real. Not to submit tiny expense amounts. Is that actually? But the thing is, it's like it should, if there were a pattern, you would expect, well, here, am I, so I wasn't looking at it with this perspective before, but if uh, maybe low, I'm not even sure which one is okay. If you just take receipts versus payout, um, I could be convinced that it's flat down at the low end. Hmm. I could be convinced that it's flat down at the low end. So receipts less than, uh, hmm, okay. So let me, hmm, okay. Okay, I'm going to start a new one, and I'm going, let's see, trips up to 7 days, filter 0.49, 0.99. Okay. I've got too many going. I'm going to save just in case, but this, public cases. Okay, row number. Okay, so this one I've already split it based on early and late. That didn't look like a thing. I'm going to delete, don't save. This is my best estimate. Yeah, so I have this, no, I have, no, that was in my other sheet. Okay, all right, I'm going to save. I'm going to start over with this guy. Okay, and I'm going to put in like the best formula that I know of for each thing, and then see if okay, so I'm going to rotate these guys so that they're like this, then I can get a little tighter. I'm going to also add a row number. Okay, so that if I start sorting things around, then I can always get back if there is a chronological trend that I want to try to fold in. I haven't lost all that stuff. So I say, okay, my other one, public cases edited. This one I had a cap. Okay, so I'm going to say is 0.49 if, no, it's going to be 1 or 0. So if uh, receipts minus floor receipts times 100 round equals 0.49 or 49 10 floor round. Num digits. Okay, So here we got 0.49. All right, we're also going to do 0.99 because I think they're different. Is 0.99. Okay, so if this guy and the floor is equal to 99, okay, then, so here's one. Okay, so now I can, so let's cap, I'm going to say um, receipt cap limit, receipt cap upper, which I had 1081. Okay, and then I say capped receipt equals min this that. Okay, that's $1. Okay, capped receipts. So now if I were to plot these two, okay, then maybe there's a lower limit because that's what I was saying here. I could convince myself that down here it's lower, but it's not zero. It's not zero in the sense it's not zero, or is it? Well, or you could just consider it a constant. So I'll say lower cap amount, receipt cap lower, and maybe that's 500. Like you get a standard deduction or something. A lower receipt price cap receipt. Max capped receipt or lower capped receipt. Am I going to do minus 500? Okay, well, anyway, twice capped receipt. Okay. No, $8 sign. Okay, so now prediction. Now on this one, mileage rate, mileage offset. Okay, how did I say mileage rate? Mileage allowance equals miles times mileage rate. And receipt cap and duration. Is there where's my per diem? Did I have a per diem in here? Oh, yeah, my per diem was 50, 100 per diem days. Okay, so now I'm going to do per diem equals days times that. Okay. And then, okay. Prediction is per diem plus mileage plus capped receipt. Okay, now if I plot expected output versus prediction, that's kind of okay, but not very good. prediction. Okay, error. Positive error means I've predicted too high, so I'm going to do prediction minus output, and then sum square sum of the squares of the arguments. Okay. All right. Sum squared error. 15,000. Okay. Okay. Now, so error. So now, in this one, I had a thing where every 3 days there's an additional penalty of 75 based on a thing. So let's see if I can reconstruct that. Days versus error. Okay. So I'm overpaying after 8 days by how much? Should I just eyeball this? Okay, I'll say second week penalty per day. Okay, so I'm going to say starting on the 8th day, 1, 2, 3, 4, 5, 6, second 6 days, there's a 400 penalty. So I'm going to penalize 400 over 6, starting on the 8th day, per diem. Per diem penalize for long trips. So I'm going to do this minus penalty times max 0 days minus 7, maybe. So that's going to be number of days over the first 7, limited to 0, number of days after the 7, multiplied by the second week penalty. Okay. Now I'm going to make the prediction depend on that, modified per diem. This is the same. Minus 7. 11 minus 7. Okay, yeah, dollar sign. Okay, now this should flatten out, maybe. Okay. Error versus days. Okay, now I want to look at error versus is 49. No, I want to look at, no, I'm going to filter. I'm going to filter on is 49 true, and I'm going to look at each of these. Error versus days, error versus what's that? Error versus miles. Error versus receipts has a pretty strong relationship. Error versus receipts, 0.49. Okay. What if I turn this off and turn this guy to, oh. Receipts 10.99. Are they the same? No filter, no filter. Is 0.49 or 0.99. I'm going to do, they can't both be true, so I can add them together. Huh, the error is pretty consistent. Oh, look at that. There's a, is there a lower cap on receipts? Oh, twice capped receipts. So, okay. So this is the shape I was expecting anyway. Is it just a scale factor? Output versus error. Why is that so? Why is that? Okay, because the lots of things contribute to the output besides the receipts, but the receipts behave as if, so the 0.49 effect primarily, okay. So if I look at twice capped receipt versus error, that is pretty darn good. Well, I mean, relatively. What if I'm looking for 1.2 times, okay, twice capped receipt. So error, positive, means my prediction is too high. So I need to lower my prediction by 1.2 times the capped receipt. Minus, okay. Let me see when I unfilter these, so 1.2 times some factor of the capped receipt. Okay, so I'm going to remove the filter. Okay, 1.2 round off penalty. So I need to subtract this much. Okay, so friction minus round off penalty times the capped receipt. Okay, so now when I do this, the error should, or this number should go down. That was really bad. Okay, that was really bad. Oh, no. Round off penalty times is 49 or 99. So it's a subset of the rows that are affected by that. It did go down. See, so these are all 0.49s and error versus days. Error versus uh, error receipts. So these are all 0.99, 0.49, 0.99, 0.49, 0.49, 0.49. So when I just like they're too negative. Okay, what's the value that minimizes this? Just change that one value. 1.12. Huh. So it was, even though these are kind of outliers. That's so weird. Okay. Well, maybe it's another rule and not just a penalty on the receipts. Okay. Offset. So this is like if there's a base, so the receipts are capped on the low end, but maybe there's a bonus if it's, or not a bonus, but a base. If you don't claim anything, then it's then you get a certain amount. If you claim below a certain amount, you just get it bumped up to a certain amount. So I'm going to say offset of 300. All right, and so prediction, I would say minus offset. So this is if you had no days or, okay, let me solve, I'm just, let's see, copy these, sorry, okay, I'm going to solve based on those, see what we get. Okay, 3,000, what was that, 10,000? 5,000, 3,000. Okay, errors versus receipts, errors versus days. Some of these are, okay. With some squared error. Okay, well, so these are pretty close. Receipt cap upper, receipt cap lower, mileage rate per diem base, second week penalty per day, $50, not 66. Round off penalty. Okay, weird. Okay, error versus receipts. Let me say error versus miles. Interesting, there looks like there's maybe a combination of high miles and something. Error versus days, miles, receipts, error versus row number. Yeah, there's nothing there. Okay, receipts. So, and these are, okay, so high mileage. Well, let me implement this into Python and see if the score goes down. It should, because I think this is similar to what I did before, but a little more expressive. So let me, don't need interviews. Okay. Calculate reimbursement. Okay. I'm just going to try to save some typing. Implement these as Python variables. Receipt cap upper. Okay, but I don't want it over there. I want it here because it's kind of a local. Oops. Okay, reject that. Okay. Okay, receipt cap upper. Receipt cap lower, mileage rate per diem base, second week penalty per day, round off penalty offset. Okay. Now if I go here, okay. Trip duration days minus, okay, per diem penalty equals per diem. Can I just I mean, I can just type it, but max trip duration days minus 7. Per diem penalized. Okay. Second week per diem penalty, max 0 trip duration days minus 7. Okay. I said accept. Okay. And then mileage allowance. Mileage rate times miles traveled. Twice capped receipt is min, max, receipt cap lower. Okay. Twice capped receipts. Min with the upper, max with the lower. Okay. Then mileage per diem penalized for long trips. Okay. Minus is 49 or 99. Okay. is 49499. Round equals 49 or 99. Okay. If is 49999 round off penalty equals penalty times I2 times H2. I2 times H2. So basically capped receipts. Twice capped receipts. 0. Okay. Prediction. Per diem penalized. Reimbursement. Per diem penalized. Mileage allowance. Twice capped receipts minus round off penalty. Per diem penalized. Per diem penalized. Mileage. Twice capped receipts. Round off penalty. Okay. Round reimbursement 2. Is that going to help? Okay. I'm going to print reimbursement. I'm going to set a breakpoint and I'm going to run. No, I can't set a breakpoint. Okay. Print. Oh, it's running multiple. Damn. So this guy can't print. Okay. Well, anyway. I can just calculate it explicitly. Run. 393 1.42. 617.37. Not even close. Okay. Offset. Oh. Plus offset. 825.07. Even worse. Minus offset or plus offset? Maybe it's plus offset. Minus offset. $4,967. Okay. 155 3.6. 155 3.6. 247.89. 137 17.97. 244.49. Okay, let me do one of the .49 ones or 99. Okay, 3. 117 21.99. 153.2. Let me try the previous one. The one above. 317 2121 21.17 421.56. So why is this one not? No roundoff penalty. What the fuck? 153.29. 3 1 oh shit. 3 117 21.99. Okay, we got a per diem penalized. We got mileage allowance. We got twice capped receipts. Total reimbursement. In case it somehow gets messed up on the output. Per diem penalized. 218.46 mileage allowance. Mileage rate 0.42707 times miles traveled. 117? No. 117. Oh, no, not 21.99. Yeah, the 421.56 is correct. This is the wrong one. Okay, per diem penalized. 218.46 mileage allowance. 49.68. Twice capped receipts is 359.410. Round off penalty amount. Round off reimbursement. Round off penalty is 266. That doesn't sound right. Oh, twice capped receipt is outputs, not, oh no. Why is, okay. Okay, per diem penalized. K11 is mileage allowance. Twice capped receipt. And then round off penalty times I11 times 1. Capped receipt, not, this should be J11. Whoops. Okay. 3440. I guess I should reoptimize that. I don't know what that was. Anyway, so I'll reoptimize it. Solver 3439. Okay. Okay, now when I run this guy, I should 117, 160.588. Yeah, pretty unpenalized. 217.84, 49.52, 355.70, 258. Where am I? Round off. Oh, round. That's implicit reimbursement 160.58. Okay, let's do the first row again. 393 1.42. Okay, 409.2916. 155 2.6. 72. No, 247.98. 247.98. Okay, so this looks good. Let me do the third one. One more. 1.47. 17.97. 244.59. Okay, that looks good. All right. So now, calculate reimbursement. All right, now we'll try the overall eval. Oops. Oh, okay, anyway, that's fine. Ah, crash. Fuck. No, oh, no successful in printing all this extra shit. That's why. 'Cause yeah, okay. Well, I'm not aiming to win, or I'm not expecting to win, let's say. 8. Is that lower? Ooh, ooh, 88.33. That is actually a lot lower than I expected. Hmm. Um, leaderboard. No, that can't be right. That would, so I'm looking at this. I mean, this is old now, a few hours, but that would put me competitive with that. That's kind of, I don't know if that's, I don't know if that's, uh, huh, that's weird. Um, let me, part, probably done. Okay. Um, bizarre. Okay. Well, if, let me see if there's anything, what other patterns might be hiding. I guess I could submit and, GitHub, how do I, okay, submit is, okay, submission form. Okay, generate results to generate final results. Submission form. Oh, okay. I have to commit to GitHub hosting implementation. Okay. License. Okay, so let me go ahead and fork the uh okay, hold on. Let me okay. I'm gonna fork topcoder challenge. Copy main branch only, forking in your personal account, fork, and then I gotta figure out how to um, can I change uh, settings? Here we go. I'll make this a private. I mean, not that it matters, but I don't want someone to scrape it. Fucking hell. All right. I'll no, 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 no. Okay, never mind. I'm just gonna create a new one because I grabbed the files anyway, so it's the same. So it's got README. MIT license must be okay. So I'm gonna make a um, new repository. Okay, I'm gonna take the top coder challenge. I'm going to delete danger zone. Delete this repository. Oh, change visibility. Oh, I can't change the visibility of a fork. Okay, so that makes sense. Delete repository. Yeah. Uh, mhm. Okay, so overview. So let's say I make a new one. Uh, Chamath challenge. Okay, I'm gonna make it private. I'm gonna add a, nope, it's gonna be empty. License. Oh, okay, no, I'll add that afterward. Create repository. And then I will add origin branch push. Okay. So I think I'm going to keep going, but I want to commit and thinking about submitting, and then I can submit later. But if something happens, like you know, something happens, I'll at least have this. And I don't know if it'll show up on the leaderboard because there's this leaderboard. Anyway, the leaderboard, this guy. Um, where's the leaderboard? This guy, like 8,000 is like crazy. And anyway, so anyway, that's the. I'll keep going, but I want to complete the submission in case some something happens or whatever. I'm surprised that my solution is a contender, even though. So, but anyway, yeah, I'm gonna keep going. Let me before I do that, let me make sure what branch I'm on. Master. Okay, so I push. So I've got Chamath challenge. It's got stuff, branch, main. Okay, interesting. Main, okay. And then add I've got to make sure I add what was your score from eval.sh? 883. Upload your private answers.txt file here. Okay, so that is from running the generate results. Yeah, so yeah, I'm at 8, which yeah, I'm not quite sure what to make of that, because I would have thought that there's like 10,000 people on Twitter probably um, looking at it seriously. I don't know. Um, I would have. I don't consider myself to be, that level of ace. So a little weird. Maybe some of the leaders are playing it closer to the vest and uh, not revealing. Okay, so submission. Oops, oops, oops. LinkedIn, resume, X, Twitter. I think that's right. Is that who I am? It should be. I'm not at all on Twitter. Is it case sensitive? Repo includes. Okay, I'll add that. Okay, let me minimize, get some of this stupid stuff out of the way. Add to my repo. Okay. On GitHub, how do I add someone to a repo? Settings, collaborators, add people, add collaborator. This looks like, okay. One invitation, okay. I guess that's this guy, 8090. Okay, that sounds right. Okay. Run.sh follows specifications of the README. Okay. Private results text file follows the specifications in the README. Okay. Each line contains a result for the corresponding test case. Private results. Add this. And this should have 5,000 lines. 5,000 lines, okay. MIT file. I'm not looking for employment. By the way, if someone else besides 8090 is interested, it sees this and is interested in employment, I'm not really interested. So um, anyway, oh, add here. Okay, but it should also be included in the, okay, so this is in private results.txt. I'll do this too. Okay, so I'm not gonna fill this in. Let's see. Okay, and then I need a license. Let's see. Is there a straightforward way to add a license file, for example, MIT license in GitHub? Go to your repository. Yeah. Okay. Oops. Click that. Shit. Interrupted. Okay. Uh, please continue. I think tell me how to add an MIT license to a GitHub repository. So what I'm expecting is there's a button somewhere I can just say, yeah, do it, and it'll go generate the license.md. Oh, okay. Create new file, name the file license.md, choose license template. Okay. There's not a license already here, right? Okay. Create new file, code, no, found on the code tab, select add file, here we go, create new file. Name the file license.md, choose license template, discard changes, MIT, 2025. I am giving everyone permission to use all this stuff. Commit, commit, commit directly. All right, so now I have license. Didn't do license.md. Okay, anyway, doesn't matter. License, and now from here, I should be able to pull. Okay, and now I have license, and now I can push commit. Okay. Yeah. Eval score of 8833. Commit, push. Okay. So I think I've checked all the boxes for this submission. Spam. Everyone has my email now. MIT license file in the root. 8833, right? Is what I said. Okay. Required. Okay. Shit. I'm going, let's see. Sorry, this is something I uh, continue. Okay. Uh, I think that's me. Let me try a new. Okay. I'll see. Okay. All right. We'll try this. Okay. I will say, where's me? Uh, okay. Uh, okay. Begins now. There's my reply. Sarah, fingers crossed emoji. Fingers crossed. Okay. All right. But like I said, I'm going to keep going. I don't know if, I don't know what, I can submit again. Got to, okay, sorry. I doubt there's 10K people taking seriously. Yeah, do not, no idea. 11,000 using regression. Okay, scores leaderboard based on 5,000 evals. So divide by five. I think the way the score is calculated is, um, I was looking at um, average error. So the score is average error times 100 plus number of inexact matches um, times zero point 0.1. So average error would not scale with the number of test cases. The number of incorrect matches would scale. So if you had, let's say, I mean, I have 1,000, almost like all of them are not exact. Um, it, so I have 1,000 that are not exact matches times zero point 0.1 would be 100. So I get 100 I get 100 score from being wrong on all the cases. If that's 5,000, then I would have 500 score from that. But the average error, I think, would not. That's this average error, 8733 times, yeah, 8733 turns into 8,733 plus 100 is how 8833 score goes. So I think the final results scoring is uh, might be on a similar scale. So don't know though. I mean, well, I guess we'll I guess we'll see. But I guess I would expect at least a 500 penalty. So sorry, 100 test cases. Sorry, 1,000 test cases will have inexact results on 100. So I get 100. So going from 1,000 to 5,000, I would expect a 400 unit increase in score. Um, so that's so instead of 88, it would be 92, 33 is my guess at what the final score would be. So, but who knows? Okay, license is ready, and I think so. I think that's all good now. I mean, this just looks like noise. I mean, obviously, there's going to be some pattern in there, but okay, what? So what's next? What is next? Okay. Okay, so if I look at is 49 versus the prediction, the, sorry, let me look at relative to the error. These are, it's a pretty wide, so let me, if I, okay, so let me try filtering on the ones where we do have a error and then look at um, receipts versus error. Let's say, oh, there's a total receipts. Oh, twice capped receipts. So why? Uh, mm, 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 plus an offset. Damn. Okay, so when I did the solver um, to optimize the coefficient to correct for the roundout, so this is my roundoff, it's just a scalar of number times the twice capped receipts. And it, in general, could be a scale and offset. And so the scale is going to mean, on average, the error is zero. That is, if I take the mean, this will be zero. But it would be lower if I were able to actually do a linear trend here. Now, if I look at the error versus total receipts, instead of error versus twice capped receipts, if I go back to, so I think I messed up this. So let me set round off penalty to, okay, starting guess. Uh, First optimization. Okay, I'm gonna take these. I set round off penalty to zero. Okay, now when I look at, now I filter by round off. So this is sort of, so if I look at twice capped receipt, so I guess which of these is a better, I already have this, which of these is a better predictor? On these, I get larger. Oh, maybe I can do it. Can I do R square valued on this guy? Add trend line. Okay. So R squared is better using the twice capped receipts, but I need an offset in order to actually get this. So I'm going to add an offset to, okay, uh, round off penalty, round off offset. Okay, so it'll start as 0, so 0.72. Okay, so this is 3439. Oh, it's a prediction. Minus, uh, minus offset times is 49 or 99. So this is an offset that will apply only when the round off is in effect. So if I say 10, 3444, 3439, minus 10, 3435. Okay, so this will be some kind of a negative value. So now I'm going to go back to solver. I'm going to go based on all of these numbers. So 3439. Oh, times H6. So why is it not? Okay, that is weird because I can manually lower it. 3439, 3431. Minimize Q2 by changing V2 to V9. Oh, unconstrained variables non-negative. 3360. What was it? 3431. Okay. So that's, I'm not going to submit again until I get close to the end, but let's see what that would do. Calculate reimbursement. Calculate reimbursement 3. All right, now we have round off offset 323.54. Okay. All right. So now I will say update the values in calculate reimbursement reflect the Excel image. Okay. receipt cap upper. All right, I'll just accept and then validate. 1153.77, 359, 8803, 426, 325, 73, 57518, 4962, 067, 1111, 215.683, negative 323519. Okay. Round off penalty, plus or minus? Minus, minus, round off offset. All right, let's try the eval, see what happens. Eval. I mean, unless you happen to, yeah, I think 0 is overfitting. I don't think it's realistic. Well, I don't know. Anything's possible. Yeah, unless you reverse engineer the random number generator that was generated or something. It's like, yeah. If there's that joke about how to determine if a number is even or odd. If 1, true. If 2, false. If 3, true. If 4, false. Whatever. I could make a program that had 1,000 if statements and got all right. 10, 338. This is worse. Did I get the polarity wrong again? Wouldn't be the first time. I mean, I guess it's conceivable if you had a way to generate millions and millions of random programs, millions of short programs, um, and throw everything against the wall or do some kind of optimization, then maybe you could stumble upon a giant algebraic expression that calculates it, with conditionals and ifs and whatever. Um, but I think manually, like I'm doing it the hard way, 8580. Oh, okay, nice. Uh, Fours try with constant round off offset re-optimized 85. What was it? 8580. So it looks like I'll be submitting at least one more before the end of the day. Um, if you generate a bunch of random programs and you happen to stumble upon the formula, then yeah, you could get 0. But I think people are probably just making mistakes. Or let's see, caps, internal caps. Yeah, this is no longer, it's kind of a scratch pad. Okay. Uh, hmm. Okay, so that's better. Copy. I think this is just a copy of the other guy, right? Yeah, I'm not different. Okay. I guess we'll say round off constant. I round off constant. Now 80, 85, 8, what was it? 8580. Add this commit. Let's see what else. What else can we maybe find? Okay, so now if I filter on this and I do a correlation between receipts and error, whoops, whoops, um, it's basically just noise. Miles traveled. Days. Now I could overfit this for sure. Well, overfit. I don't know if it's um, if I create a polynomial piecewise linear something such that only when the round off is happening, that is 0.49 or 0.99, then it applies this compensation. The uh, the eval score would go down, but is this a coincidence? That's not true in the validation in the private results, or is it a real effect? Don't know. This is kind of interesting that these two stand out. Hmm. These are consecutive. Um, okay. What if we look at okay, what else can we errors versus miles? There's a bunch of these that are, so what if I screen these to only be non-round off cases? So like this dot disappears. Okay. But all these down here are, so let me see maybe if um, hmm, receipts. I guess are these the same ones as these? If I what if I filter on error greater than filter on well, no, I gotta be careful. If I filter on error, then I'm going to be uh, at risk of some kind of overfitting. If I filter, well, any kind, even filtering on miles, or this is like long. So low value means so the error is the prediction minus the truth. So low means I've underestimated. Negative means I've underestimated. So I'm severely underestimating for long trips with low receipts. So maybe there's a rule where so let me look at, um, and maybe this is so anyway, so let me look at long trips longer than, what's this, 1,000. Um, filter greater than 1,000. Okay. Now I'm looking at uh, receipts versus error. Long with low receipts. So, I mean, it's possible to overfit with this kind of a, this is kind of a, interesting, 1,000. Okay, What about us? So these are long trips. What about long trips? Sorry, long trips of short duration, I'm overpaying. Long trips of long duration, I'm underpaying. Well, maybe. I wish I had a better way to view this in a multidimensional. So this is error, this is duration, this is error, this is receipts. What if I bin them by, well, let's see. Well, I know that these ones with that are negative that I'm underpaying are long trips. Sorry, yeah, long duration trips. So long long trips that are long duration I'm underpaying. Long trips of long duration, I'm underpaying. I mean, I could make a rule. So let me go back to the, let me turn off this filter. Let me just look at long duration. Oh, duration. So these are long duration. Now if I take out, yeah, that's not different. Yeah. So let me look at 7. What was it? 7 or error versus duration. 1, 2, 3, 4, 5, 6. So 6. 1, 2, 3, 4, 5, 6. Maybe 7 is even a rule. Maybe 7 is a rule by itself. Let me look at 7. Okay, 7 days. Let me look at receipts versus error. I don't think that's miles versus error. Huh. Miles. There's definitely a trend there. So 7-day trips. There's 7-day trips. There's a trend. What about? See, I need a way to. If I stretch this guy and I put this up here, then I can change the filter without. Okay, 1-day trips. Okay, 2-day trips. 3-day trips. Okay. 4-day trips. And this is, so the slope is 0.12, the R squared is 0.24, 0.12, 0.24. So these are the same, basically the same trend. 5-day trips, nothing really. 6-day trips, nothing really. 7-day trips, I'm pretty sure there was something. Weak negative trend. Okay, let's see about 8-day trips. 8-day trips, weak indeterminate. So I don't know if that's a weak indeterminate, maybe offset, because it's got a 9-day trips, nothing really. 10-day trips, nothing. 11-day trips, all right. 12-day trips, nothing. 13-day trips, nothing. 14-day trips, nothing. No, nothing. Okay, so 3 and 4 is definitely something. That looks actually like 2 segments. 3 and 4-day trips. So 3 and 4, do they look the same individually? Both of them are kind of flat and then tick up. Flat until what? Until like 1,000? And then tick up. 3 and 4 together. Yeah, I'm going to say they're flat until 3 and 4-day trips. Weak positive trend. Looks like piecewise linear up to maybe, I don't know where that cutoff is, maybe 6, 7, maybe like 900. About 900. About 900. 7-day trips. Okay, so let me say, let's say it's piecewise linear. So how am I going to implement this? So 3 and 4-day. So I'm going to have a constant, a cutoff, and a slope. Okay, so let me turn off the filter. Okay, 3, 4, cutoff. Let's say 900. I'm gonna good 8480. What was it? 8580. Copy these guys now. Okay, 3 to 4 cutoff. I'm saying it's 900. The slope is 3 and 4 slope 3 and 4 offset. Okay. Let me say 3 and 4. Okay, what kind of slope? This is what goes up about 100 counts from 900 so or 300, so about 0.3. 0.3. And then an offset is, I don't know, maybe negative 50. I'll just, as a starting point, negative 50. Okay, so prediction. Okay, I gotta put this guy in the way. Insert 3 and 4 correction depends on miles. So this is if this equals 3 or if absolute of this minus 3.5 is less than 0.6, 1, 0. Okay, so this should be 3 and 4. 3, 3, 3. I don't know, 4 is up here. 3, 3, 3, 4, 4. Yeah, okay. 3 and 4 and none of the other ones. Okay. Times okay, so piecewise linear function. Piecewise 3 and 4 correction filter. Okay, 3 and 4 correction function is on miles. So this is going to be offset $signs plus slope times miles minus cutoff. Okay, max 0 miles. Okay, dollar signs. So it's offset. So it'll be the function value up to the cutoff. Once it reaches the cutoff, it'll increase to the max of 0. Then it'll increase by the slope. Okay. Okay. Minus 50. And then it goes up as the mileage goes up. So if I were to plot miles versus correction function, negative 50 up to the cutoff, then it goes up with a slope of 0.3, which is, or 300, it goes up by 100. Or negative 50 to plus 50. 0.3, oh, 3/10. 0.33 is 1/3. Okay, yeah, okay. So now the prediction is going to incorporate the filter times the correction function. So the filter will screen it so it only applies to 3 and 4. Now we'll see if the root squared error goes down, maybe, but it's still not optimized. So maybe 35, what was it? 3360. Do I have to subtract? 3361. 3312. Okay, now I'll solve as a function of these guys. Solve. 3,200. Okay. Now, number 7, day 7, 7-day trips have a trend also. 7-day trips have a trend of miles versus error. Now, is this a linear or is this also a piecewise linear? I'm gonna overfit, but I think it's I think it's okay. I'm just gonna wing it. Okay, so I'm gonna say it's got a cutoff of 7-day. Okay, 7-day offset of maybe 50. Cutoff of 600. Slope of like if I went from here, so over 600, it went down by 2 clicks. 200. That's again 1/3. Interesting. Slope of negative 1/3. Okay, so let me. Oh, I guess I could look at. Let me look at 3 and 4 because it should be flat now. Yeah. So I mean this is optimized, so it's not surprising. But okay, so look at 7. Okay, so I'm going to turn off the filter. All right, so I'm going to say 7-day was 50. 7-day cutoff was 600. 7-day slope. Why aren't we using ML? Yeah, well, this is. I'm just using my eyeballs to to see the shape. So uh, I don't want it to. I guess ML. I need to search over formulas. So I don't know how to do that. So I can guess with formulas and then tweak the coefficients, and that's what I'm doing. But the search is actually happening in Excel, doing Excel for the optimization. Minus checkpoint. Okay, so now I'm going to say 3 and 4 correction filter function. Okay, I'm going to say 7-day correction filter equal if days equals 7 when 0. Okay, so this is true for 7 days and false for everything else. And then the 7-day correction function is offset. These are cutoff slope offset. Cutoff slope. This doesn't matter, but just a little bit of consistency. Okay. Equals offset plus slope times max 0 miles minus cutoff. Okay, I gotta do my dollar signs. Okay. So now if I do miles traveled versus correction function, I should see, and it drops down by 200 over 600, starting at 600. So that function looks right. Now the prediction, 30, I keep forgetting what the value is. Prediction, I'm going to minus that times that. Okay, 32.25. Okay, not too exciting, but we'll see. After we optimize, $32.25, $32.06. Okay. So I guess now I can try implementing in okay. Is 3-day or 4-day? Okay. If okay, oops. 3 or 4 adjustment equals miles traveled. No, miles traveled. I gotta implement that threshold. Okay, if is 7-day. 7-day adjustment equals, okay. 3 or cutoff. Oh, I gotta change all these values. Fuck. 3 or 4 cutoff equals 4. 3 or 4 slope equals 0.62. Ooh, that's steep. It was like 0.3 when I was eyeballing it. Okay. Let me look at 7. 7. Yeah. Yeah, that's yeah, I guess that's decent. Okay, 3 or 4 slope, 3 or 4 offset equals negative 49.45. 7 cutoff equals 567. 7 slope, offset, slope. Oh, I got this backwards. Offset equals negative 3.6. 7 slope, negative 0.1. Okay. Okay. Move this stupid thing out of the way. Update the coefficients in the calculate reimbursement function to reflect the values in the image. Okay, 115077, 360, 4891, 444, 506, 709, 5184, 144.0, 08037, 11977, 2206743, 17929, 82499, 625, 295, 4491. And I'm doing them in the same order: cutoff, slope, offset, cutoff, offset, slope. Okay. 5679698, -362,037, -21854. Okay. Miles traveled times, okay, max, oh, wait a minute. Yeah. Miles traveled minus, max 0 miles traveled times, no, miles traveled minus 3 or 4 cutoff times 3 or 4 slope plus 3 or 4 offset. 7-day adjustment, max mile traveled minus 7 cutoff times 7 slope plus 7 offset. And this is subtracted from the prediction. Yeah, because the error goes up, so I have to subtract it from the prediction. No. The error is positive. I predict a value. I subtract that value. So the error will go back to 0. So I just have to subtract it. Okay. Okay. Plus, okay, but it's minus 7-day adjustment. We will see. I don't know if this is, I got a 50-50 shot, or no, I got a 70% chance of being wrong on the polarity, but I guess we'll see. So that previously was 8580. Okay, with, okay, no. With piecewise linear 8300. Okay, it's predicting what my score will be. 8227. It's even lower than that said. Okay. I'm surprised, I guess. Calculate reimbursement. Piecewise correction for 3, 4, and 7-day trips. 8227. Unsafe change. Oh. Okay. 85,880. No, not right. 8580. Okay, so now what? I mean, the more I look, the more it looks random. So now if I do 7-day trips, it looks kind of flat. If I do clear filter, okay. So this is error versus. Now I've already got these plots elsewhere. Okay, error versus days, error versus miles, error versus receipts. I wonder if maybe this one is informative. 10:25. No, it's yeah, 10:25. Maybe that will tell me something. These guys. Um, 10:25. All right, let me color code this guy. Um, Wait a minute. Hours versus miles. So miles of 10:25. But the order. This is number 513. Okay, anyway. The early ones have a different distribution. But then they also have a different distribution. Okay, let me, because it was what, if I look at miles traveled versus road number. Road number versus mileage. Okay, so there's a ton, it's about 150. There's a cutoff. So let me do less than or equal to 150 to 150. There's a trend for those. Greater than. Oh shit. Greater than 2. So there's not really a. So these rules work well for the bulk of it. The early ones have a funny. So the 1-day trips, the early 1-day trips, but I can't condition on early versus late because each one is, I mean, it's stateless. So there would have to be some other clue, You are not in there? What? Oh, new leaderboard. Okay. New leaderboard. Okay. Well, I mean, I might have a bug or something. I don't know. If you submitted but don't see your name here on here, reply with the name you submitted with, and I'll give you a private set score. Okay. I posted name Kawabata. All right, we'll see. Okay. So early, so one day, okay, what if I filter on day one? Oh, sorry, one day. One day and early miles are one day and early. The trend is high, but it doesn't look like it's dependent on this. If I clear the filter, oh, receipts, day one. No, I already did. Oh, I did. Okay. I put in special rules for day 3 and 4 based on miles. Well, I didn't look at day one as a function of receipts or individual days as a function of receipts. So day one receipts has a trend. So let me look at all the let me look at all the days based on receipts. Uh, okay. Uh, oh, day one and day two. Okay, I'm not going to update now. 0.39. That's really strong. Well, strong enough to make a difference. 0.39, 0.37. What about day three? 3 day. Weaker, but still, well, I don't know. Is that a piecewise linear or a quadratic floor? Holy cow, these are super strong. Day 5, yeah. Day 6, yeah. Day 7, nope. Day 8, positive. Day 9, R squared is not that bad. Hmm. Um, day 7 was 0. Day 8, very weak positive. Okay, so as a function of miles, no, as a function of receipts, day 7, no correlation. Day 8, weak. So I'm going to see if I can view these at the same time. Day 8, weak. day 9, day 9 week positive 0.06, day 10. So if they have the same slope, then I could lump them together into a single function that does, 0.03 week 0.036, day 11, day 11, week 0.047. Because I mean, the point is not to minimize the minimize the residual error, but to score well on the private cases. So day 12, day 12 moderate 0.06, day 13. So 0.19 is, I just said that was moderate. Yeah, 0.09. So this is like half. Day 13. Day 13, very weak. 4. Day 14. 0.056. So what I'm thinking is if I could group these together, like 13, 14, 10, and 11, maybe it's got that's still 0.08. That's hardly worth it. But then day 9 and 9 is r squared of 0.14, and day 12, 0.19 with a similar coefficient, so I can group 9 and 12 together. Okay, so day 9 and 12, similar slope, maybe, because it was wait a minute, 9 is 0.59, 12 is 0.60, 12 and 9 together, 0.54. This is the, what do they call it, Simpson's okay, anyway, that's something. What about the shorter days? I remember seeing something was day 2, so 0.39 is very strong. Okay, day 2, very strong, negative 0.06. So those could be grouped. Number 3, day 3, moderate, 0.03, because only 0.12 is quite different. 4 is moderate. Now that's pretty strong. Minus 0.05. 5 is weak and minimal effect, minimal slope, day 6 week, minus 102. Eight week, 5. Okay, so not, I said 9 was weak. 0.148 and 12.19. 19 r squared. So I'm gonna group 9 and 12, and I'm gonna group. So let's see. Do 1, 2, and should I group 1, 2, and 4 together? That's pretty strong. So what if I group 1, 2, and 4? 0.38. That's pretty. Now is that piecewise linear, or do I just whack a line through the whole thing? It looks piecewise linear to me again. 1 and 2. Yeah, that still looks like 1 could be piecewise linear. 2, kind of hard to tell. 4, also kind of hard to tell, but it is. Okay. Now, I guess I'm not too scared of overfitting if I'm doing a piecewise linear here, because it's not like I'm doing some, fine, some fine adjustment. Let me see if they. Seven. I mean, I might just be higher than this because I was predicting. I said 88 plus a margin of going from 1,000 to 500, 1,000 to 5,000 should add 400. So 88. It was 88, right? 8833 plus 400 would be 92. So uh, that would put me out of the top 10 for now. Let's see. So 1, 2, and 4 piecewise linear. And then I'll do a, well, let me do that first. Clear filter. Okay. I need more room. Okay. 8580. No, it was 8850. 8580. This was what? 8227. Okay. And, 1, 2, 4. Receipts cut off slope offset. So error versus receipts, and then I'll do 1, 1, 2, 4. So offset of 50. cutoff of 1200, slope of negative 0 point, what, double the slope, or 0.009, okay. Okay, insert, insert, 1, 2, 4, filter. If days, I guess it's or days equals 1, days equals 2, days equals 4, and 0. Okay. And then the correction, 1, 2, 4, function is piecewise linear, which is equal to offset plus slope times max 0 or receipts minus cutoff. Okay, I gotta put dollar signs in these guys. Okay, so it's 50, and then so I do receipts versus the function, 50, and then drops at a rate of 0.09. Okay, and the prediction, I'm going to subtract the filter times the function, and then 3146. Oh, what was that? 3206. 3206. That's my previous best, or previous. Okay, 3146. So slightly lower. Now I will solver based on these numbers. 3099. So what was it? 3146. So the solver drops it by another little bit. Okay. Now if I filter by 1, 2, 4, it's pretty flat. It's pretty flat. Yeah. Okay. This is like the worst possible version control. Okay. 1, 1, 2, 4. Day 1, 2, 4. Cutoff. Day 1, 2, 4 slope. Day 1, 2, 4 offset. Okay. Offset 76. Okay. All right. Now I'm going to update these coefficients according to the image. It's easier for me to validate the results than to type 100% correctly. I mean, even if I type it, I have to validate it, so or I should. Um, I wonder. I guess I should check. Maybe there's a comment on GitHub or something. Did I close? I closed the GitHub. Oh, here we go. Don't see anything. Okay. Well, all right. Well, okay. I will accept and then check. 1130, 387, 367, 0591, 44, 0.445248, 68, 16, 136, 40, 41179, 118, 0411, 1950, 159, 37, negative 372, 779, 802, 8935, 058875, negative 41.3645, 552, 1452, 3641, negative 364171, negative 0.21659, 568.6145, negative 0. Negative 0.09559, 76.22546. Okay. Um, if days, trip duration days equals 1 or 2 or 4, I'll probably use a clever in statement, 1 to 4 adjustment. Miles traveled, okay, but it's not miles traveled, it's receipts. Receipts, total receipts, minus cutoff, plus day 124 times day 124 slope plus day 124 offset. And then this is minus day 124 adjustment. Okay. Let's see what happens. I'm at 8227, which I had here. Can I collapse? No. Okay. Wait, okay, let me just run, save, run. Eight thousand. It thinks I'm going to get 8,000. We'll see. Could be. I mean, the linear fit for miles was a couple hundred, so holy shit, 7863. No. What? Holy crap. I, hmm. Save it before committing. Wow. Okay. Well, I guess the next one was I saw there was a correlation on days 9 and 12. that I think I can group together. Is that one piecewise linear too? Or do I just whack a line through it? I think that's piecewise linear too. I mean, why not? That's small though. I mean, is that real? I think it's real. Might as well. Might as well add it. I don't know what else I'm doing. Um, okay. So 912, 912. If uh, uh, or equals 9, A2 equals 12. Okay, so this will be true for 9 and 12, but false for everything else. 9, 12, 9, yeah, okay. 9, 12 function. This was 7863. Okay, 9, 12 cutoff, 9, 12 slip, 9, 12 offset. Okay. Cutoff was, let's see, 9, 12, 1500, offset 0, slope, let's see, it goes up by what? Maybe 100 counts over 1000 counts. So 0.1, 100. Is there a rise of 100 over 1000? Say 0.1, cut off of 1500, cut off 1500, slope 0.1, offset 0. Okay, this is 912 function, which is equal to receipts, which is a function of receipts, which is equal to offset plus uh, uh, plus slope times max 0 receipts minus cutoff with dollar signs all over it. Okay, so now if I do receipts versus the function, it looks like 0 and then up by 100 over 1000. Okay, so now so 3099, 3099. So now the prediction, I'm going to subtract 3051. So it went down. Then I'm going to go back to the solver. And I'll solve on the larger set. So 3051, 3042. Marginal. These are pretty close. This was 0.1. This was 1500. So now that's probably overfitting in that sense, where those parameters have more significant figures than they really have. But anyway, it seems to help. You know what? I've got history. I've got good history on these guys, so I'm just gonna blow this shit away. Reimbursement one. Oh, did this one not even return? Okay. Day 9/12. Cutoff. Slope offset. Cutoff 1246. Slope 0.098, 0.0098, 9.2. Okay. Now I'm going to add to, come on, add to chat. Add to chat. Please update these coefficients to match the values specified in the image. So 6,000 is pretty unlikely I'll be able to reach that. But anyway, okay. 1, 3. All right. So let me. Okay. 1138.91, 367, 1785, 044, 6287, 69, 59058, 4062, 583, 1180, 749, 204, 0452, 374, 008, 801, 6925, 87, 0. Okay. 801.692, 0.587308, negative 40.6858, 538.309, 53.26171, negative 0.2118, 5721424, negative 0.08964, 70.70117, 1346.4, 0.0980709, 0.098079. Oh, that's not right. Fucked up. 709, 098, 709, 9214965. Okay. Do I need to go through again, make sure? 446. Yeah, okay. Anyway. All right. If trip duration days is 9 or 12, total receipts amount, day 9/12 cutoff, slope offset. All right, it's starting to day 9/12 adjustment. Did I already add that? No, I hadn't added it yet. Day 9/12 adjustment. Okay. I think I'm getting into the overfitting zone. So some of this is going to be unrealistic as far as, or not representative as far as the final score. But anyway, it's still, we might as well. This piece rising for 9/12. All right. Okay. But I mean, I'm not doing a 7756. Yeah, minimum. Okay. Well, we can still. I mean, I'll take it. Uh, piece. Day 9, 12 rules. Val 779. Oh, sorry, 56. Commit. Okay. So I think, like, in order to, like, 8,000, 8,000, 8,000, 8,000, 6,000, there's some secret, uh, not secret, but there's some other thing like a round off error or a, you know, mod 7, you know, thing or a, something like that. That's where something that looks random is not actually random, but um, is spread out. So I wonder if there's some kind of modulus. Okay, error versus these things. I think I've beaten these to death. Um, I can regenerate these plots easily enough. They're pretty trivial. Um, errors versus receipts. So now if I do 9 and 12, what? 9 and 12. Yeah, that's flat. There's no residual error there left. I guess I could look at modulus. Um, modulus on miles or something, like if there's some random. So and these two have pretty different. So then 0.99 is, the correction that I'm applying when, so I wonder how much, well, no, the, the bulk of so when I look at receipts versus error, the bulk of the error is not this 0.49, but I think there's some other rounding or modulus or some kind of coincident. Uh, I wonder if I wonder if hmm, I wonder if there's a, yeah. The thing is, these charts are, I'm only looking at 2 dimensions at a time. Sometimes a 3-dimensional error can manifest in a 2-dimensional view, but it's kind of hit, unreliable to see if that would do it. Miles Child. Okay, it's 6 o'clock, so I got 2 hours. Um, mm, okay. I'm gonna add a column for modulus. Or miles modulus. So this is going to be modulus. So these guys I don't need anymore. I can hide these. And this is 7756. So if there's a, so 3L42. All right, modulus is, let me say 10. It's nice and easy. And do mod miles modulus. Okay. Oops. All right, let's see what we got here. Okay, mod 3. Wait a minute. Oh, mod 10, yeah. Okay. Oh, some of these I got fractionals. Okay, well, I'm gonna kind of ignore those. 9, 8, 7, 6, 12, 13, 14, 15, 16, 16. Is that a 17, 18? This is just messing with me, I think. What if I look at subsets of days, like 1 through 7? No. Not seeing anything. 20th on the private side. Oh wow. Well, that is encouraging. Thank you for telling me. I'm not okay. Just okay. No, less than 3 hours left. 20th on the private. 20th. Nice. Okay. Okay, 94.88, which is not far off from my prediction because I predicted a difference going from 1,000 to 5,000 would increase by about 400, and I submitted 88.33. So 400 would put that 9,200, 92.33. So this is so that offset I think I can account for, plus the fact that I'm fitting to some degree overfitting to this. So if we can expect uh, let's say a 600 delta, no 94, yeah, let's say a 600 delta, 650 delta, then 7756 would be about 8,300, 8,400, 60. So add 650 to this would be 83, 8,400. So nice, 8,400. Yeah, so that's maybe, well, but these are going to, I mean, new submissions are going to be, I'm not going to be, uh, I'm not going to, probably not in the top 10 anymore with new submissions being entered. So anyway, cool. Um, yeah, yeah, exactly. Yeah, first submission. So I got more coming along. Um, so that's I uh, this is going better than I thought it would. Well, and also that this problem is somewhat not not really, but to some degree similar to what I do for work. So this is sort of my kind of problem, if I may say so. So anyway, that's I guess good for me, advantage for me. Um, I'm not seeing. Oops, mod one. I'm not seeing any modulus error or modulus relationship. Um, what about modulus? I know receipts are fractions, but what if there were some receipts modulus? Okay, let me do modulus mod 20 or something. Okay, mod 8. Hmm. Okay. Uh, so mod 1, 0.33, 0.48, 0.91. So 0.33 looks like I wonder if there's some, if there were a decimal to binary, well, okay, what if I filter this guy on 0.33? Um, no, and what are these values? 0.97, What are these? Uh, there's some trick. There's some trick. Well, maybe. I mean, I'm looking at this, right? There's some. Um, I don't think the path I'm going now is. I don't think it's possible to reach that. I think it'll be like, it'll stay looking random with maybe a, gross level of curvature or whatever. But if there's some hidden uh, bug, let's say, that's being, I haven't, well, I haven't looked at row number, and actually row number doesn't have, it's not possible for, I say that, well, if I if I don't assume it's stateless and you write to a, save to a file or something, and you take the phase of the moon into account, like these interview subjects seem to think, um, mid-month is better. Is this really a, well, no, but you would see, no, but you would see a trend over, this modulus thing is like, I'm gonna, um, if I look at error versus row number, so there are some high, okay, so something that's interesting, it looks like the high outliers are higher and the low outliers are lower on the late 80% compared to the early 80%, except for these outliers. So if there's a pattern to the input on the early, maybe there's something in the input where I can predict which ones are going to be outliers and apply a different rule to those, I guess is something I'm thinking. I'm going to first, though, take a break. This will be like a minute, maybe. My hands are sticky. I gotta wash my hands. So I will be back in a second. Okay, second place. Nice. README Claude wrote explaining how it did it. Uh, I'll take it, I guess, if you have some hints. Uh, yeah, I won't turn down advice. I don't mind. I mean, yeah. Uh, let's see, 1 hour. So, new leaderboard, less than 3 hours. If 4 hours, 1 hour. DVD. S. Uh, leaderboard. Okay, yeah. All right. Yeah. Okay. Um, so I'm going to look at. So like I said, the last 80% looks like it's got more higher high outliers and lower low outliers than the first 20%. And I already know that we already seen that there's a pattern if you look at like the early miles traveled versus row number, or row number versus mile traveled. It's like um, it's like got this pattern early and then it's more random later. So maybe we can use that to identify which uh, which conditions cause the outliers, and um, maybe there's a second rule that's applied in some certain conditions, and the certain conditions are not uh, frequent enough to show up in the overall statistics when I look at it this way. So let me look. Uh, I'm going to make a new, I guess, a new sheet where I can take the early cases. So it's like 152, I think, was um, kind of the cutoff, or what it would look like the cutoff. Yeah, 151. I'll do these. So these I'll consider the first 20%. Uh, first 20%. Okay, and then I'll copy this up to the same row. Okay, paste values. Okay, now let's see if we can establish error. So we'll do, I guess, just plot the, so I was looking, so it's error versus, so error versus row number. Yeah, so these from 134 to 149. 153, I guess, is not one, but okay. So we'll do, I guess that's these two. So we're looking at stuff below minus 204. I guess I could do the filter that way. Number filter less than 204. Okay, so we'll say these guys I'll highlight. Highlight pink or something. Okay, so this so let me, what am I going to do? I have a somewhere so I can sort by error. Sort largest to smallest. Right, and then these three Maybe there are special. Largest. Is 149 a magic value? Oh no, that's row number. I can't filter on that. Miles traveled. 1,000 is 1,000 miles versus error. Okay. 913. Okay, that's not, doesn't look like anything. Uh, 1021. Let's see, these differ by 916 to 913. Yeah, it goes down by 3. This goes down by not 15. Unless there's some formula, like some weird thing like miles per day or receipts per day. Receipts per mile. Receipts per day. Miles. No, receipts minus miles. Receipts per mile. If I do receipts divided by miles. If that's in a, now let's see, this one's also in a, okay, no, I don't know. Sorry, I'm mumbling. Okay, so if I show receipts minus miles, receipts per mile, so these errors have a pretty tight range in receipts per mile. I guess I would apply that to, okay, so what if we, receipts per mile minus receipts per mile, receipts minus miles, receipts divided by miles. Okay. Receipts per mile. So I'm interested in the ones that are really high or really low. So let me cap that at like 20. Oops, I mean, so that the ones that are below minus 200 looks like a, ooh, and then the high ones are, that's kind of interesting. That's kind of interesting. Receipts minus miles. This is Also interesting. Receipts per mile. 8K in the public set to now. Uh, what's the question? Getting 8K in the public set? So my latest eval was 7756, and I believe that there's a delta between of about 650 between the public set and the private set. So I'm predicting about eight uh, 650. I'm predicting about 840. Uh, sorry, 8400. Um, so that's the current status. Now it might be higher than 840 when it publishes. If there's something, this is really interesting though. Receipts per mile. What about receipts per day and receipts per day? These are kind of natural things that accountants would look at, I guess. Yeah, receipts per day. Okay, we need to cap that at like uh, 500. Receipts per day doesn't look that interesting. What about miles per day? It might be a conjunction of miles per day less than a certain amount. So this is what, 600, 400, 200? No, no. Let's say 300. This was receipts minus miles. Error versus receipts per mile. Let's look at all these around here. So what if I literally cut, instead of cutting at 20, let me cut at 5. See what that looks like. Yeah. Okay, so there's a bonus. This is pretty huge. This is pretty huge. Bonus for uh, receipts per mile above. Now, is that receipts per mile or capped receipts per mile? Let me insert. Let me say capped because I'm calculating a capped receipt, twice capped receipts equals twice capped receipts divided by miles. Receipts per mile. Twice capped receipts per mile. So I'll do min 10. Okay. Error versus receipts per mile. This is, remember, okay, error versus receipts per mile. Error versus twice capped receipts per mile. on the same scale. Okay. It looks like this one looks, just visually looks cleaner than this one, where it's kind of messy, where this is got a tighter range with a discontinuity. What if instead of twice capped receipts, I did just ordinary capped receipts? Which is better? I think the one on the left is still better. This has some overlap here in this region where there are high outliers and low outliers. Yeah, black box models. I don't know. I mean, this is kind of the designing features by hand is kind of the old school way that's supposed to be not very good if you're doing like Kaggle competitions or something like that. So anyway, this is, so I think error versus receipts per mile is pretty good. So I'm going to, what am I going to do? I'm going to zoom in. Oh, let me just say, where's the threshold? I'm going to say, so this one is 1.18 and this one is 1.24. This is 1.15. So where it start going high is 1.24, 1.22, 1.18. So I'm going to say 1.2 is the cutoff. 1.2 is the cutoff. Now, is it just a, are we talking a constant? No, not a well, because I've got these other coefficients that will adjust if I, so let's say I had a constant, everything below 1.2. Um, um, then even though this has a bit of a slope to it, and this has a slope to it, the optimization can adjust the, like the piecewise linear and everything. So I'm just going to add a constant. So I'm going to say low. So my error is positive, meaning if my error is positive, it means that my prediction is too high. And so I need to penalize ones that are positive. So for low, I'm going to give a bonus. So bonus for low receipts per mile. So if, so bonus amount receipts per mile bonus amount. It's a constant. And I'm looking at, what's that, maybe 100? 100 bucks? I need to insert, insert, and then receipts per mile bonus. Okay, so then if, and then the threshold is, I'm going to say 1.2. Okay, so now this is if receipts per mile is less than the threshold, then bonus, otherwise 0. And I need dollar signs on this guy. What time is it? 6:30. Okay, so the $100 bonus And the prediction, where's my prediction? Oh shit, prediction's over here. Okay. Okay. What? No. Receipts per mile. Okay. Receipts per mile is, oh, I'm cut. Well, it doesn't matter if I cut it because as long as it's below this threshold. I'm capping it, but it doesn't matter. Okay. Receipts per mile. Bonus for low receipts per mile. Prediction. I'm going to add so for low receipts per mile, I want the prediction. I'm going to get the polarity wrong. Minus, no, plus 100. Okay. Oh, that's interesting. I can just adjust it here. 110, 130, 140. Okay. Then I will solve again. Solver. Switch that up. Okay. So 3042 was the previous one. Now I'm going to solve including this guy. Holy shit, 27. Well, I don't know if that's a lot. 300. 150 bucks for bonus. Bonus. Low receipt bonus equals 150. Okay, I need a better way to. Okay, I'm gonna. What happens if I just copy paste like this? I just get a. Opt-in values equals. Can I do this? What happens if? Okay. Where's my? Fix the syntax, please. Let me save this, please. Maybe it's a line continuous. I guess I could do. I shouldn't take that long. Sheet cap buffer. Okay. Okay, just stupid commas. Right. Do I have to worry about the? Okay, no, because here it's showing these match. Okay, so the delta. All right. Yeah, opt-in value is 0, 1. Yeah, there we go. Yeah, you got it. 6, 7, 8, 19, 20. Okay. All right. Okay. If, okay. Receipts per mile divided by miles traveled. Miles traveled is never 0, right? Do I have to? It's never 0. But in the test data set, it might be 0. So I'll do max 1 miles traveled. Okay, or if it's negative or something. Because if it blows up, I might not get a score at all. Receipts per mile. If receipts per mile is less than low receipt bonus, then low receipt bonus is that. Low receipt bonus, I add predicting a plus for low receipt bonus. Okay. All right. Okay. So I guess let's see what happens. Eval. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. Nope. Minus. No, wait a minute. That's not a low receipt bonus. That's a low receipt penalty. Low receipt bonus. Oh, shit. Low receipt threshold, 1.2. Receipts per mile is less than 1.2. Yeah. Plus low receipt bonus. Yeah, because they're, yeah. Yeah, 12,000 is not good. So 77.56. We'll see. 7076. Okay, still not in the 6,000 range, but that's pretty damn good. Or well, I'm happy with it. Okay, so okay, well, we'll add this. Difference is bonus 7. What is it? 7076. Okay. Okay. Let's see what else I got. Okay, what about receipts per day? Is there anything related to receipts per after I compensate for receipts per mile? Is there anything else for receipts per day? What about or row number? Because yeah, there's still outliers for there's still outliers. Okay, if we take this, sort by row number. 150. receipts per mile. Receipts minus miles. I still got time. I think probably about another another 40 minutes, let's say. I'll uh, I'll cut it and do the submission. So I don't want to fumble the submission at the end. So I'm definitely seeing diminishing returns. Um, okay. Uh, cheers. So we got there's some there's some secret. So I think there's some secret. I say secret, but there's some condition that's like how am I trying to say it? Some edge case. So my belief, there's some edge case that is not hit in the first 20%, except for these three or four, and that edge case is hit in the last 80% occasionally, and that's the reason for the bulk of the outliers. So I'm interested in, so maybe I could, um, let me see, maybe edge case. I'm going to say this is if um, the error is greater than 170 or ouch, if or error greater than 170, error less than, what is this, negative? Let me say negative 170, 10. Okay, maybe edge case. Let me do, okay, oops. Negative 170. Okay, so now if I filter on this, yeah, so these values, so what can I say about these values? Uh, can I plot, okay, the expected output could also be, I wonder if the so, oh, but you don't have the expected output. Well, no, but you could, okay, so what I'm thinking is, I have 3 input variables and I have 1 output variable. I'm treating the expected output as untouchable because I only have the input 3 available. And so I have to generate the output from those 3. If there's some funny condition about expected output, like if expected output is a multiple of 10 or, whatever, some kind of condition, then I can't use it because I don't know what the expected output is. But so that type of, so like if I make an output prediction that's based in any way on the expected output, that's cheating, and it doesn't. I won't be able to, or not cheating, but I wouldn't be able to use that for the private set. But if there's a bug of the form, you create something, you do some calculation, bunch of whatever math, you get an output value, and then that gets the has if that value ends in a three, then it has some corruption. That is something that can be implemented, and it would manifest as a weird combination of inputs that uh, so so in searching for the error, in searching for the condition that causes these weird conditions, I can maybe look at the expected output if it leads me to something something like that. Anyway, um, or that could just be a bunch of garbage. Who knows? Let's see. So if I say um, error for no, but this isn't really helping. I need to see ones with the condition versus the ones without the condition. So how do I do that? How do I do that? Do I recopy the whole thing for the first 20? Okay, let me do, let me, I don't think I need this. Yeah. Okay, I'll make a copy of this sheet. And then instead of filtering on edge cases, I will sort on edge cases. I'll sort 1 to 0. Oops. Maybe edge case. Oh shit, I deleted my, yeah, okay. Maybe edge case. So why can't I sort this? I can filter, right? Oh, it does those. Oh no, but sorting shouldn't apply to the same columns. I should still be able to sort. Yeah. Why did that change? Okay, same value. Okay. Okay. So now if I just plot, is there a relationship that's true for these things? Okay. Receipts versus miles. Then I also do it for receipts for What's the difference? In this view, nothing. Um, so the ones with high and low expected output. So what's expected output versus error? Is it just a stupid? Is there just a post correction that minus? That's kind of weird. Or is there a piecewise linear that applies to that? Because I mean, 57 is. I mean, that's not a. Oh no, 57 is the y-intercept. Um, damn, that's kind of. Why didn't I? Um, and it might interact with the other ones too if there's a. So let me. Um, okay. So hold on. As a function of um, error, as a function of uh, expected output. I need error as a function of prediction, actually, in order for this to really work. So I have error as a function, prediction. Okay, prediction versus error. I mean, it's going to be pretty, well, I don't know, we'll see. Maybe it's, that is much less, no, wait a minute. Okay. Oh, of course the error is correlated with the, of course the error is correlated with the correct answer. Yeah, because the, okay, whoops. Okay. But what I haven't looked at modulus of prediction modulus. Modulus 10 equals mod prediction 10 with dollar signs. Okay, prediction versus error. Modulated modulo. Okay, this is going to be 5. 1. 2, 3. isn't going anywhere. This isn't going anywhere, and this is misleading. Um, hmm. Well, I'm running out of ideas. I'm running out of ideas. Maybe the biggest outlier, minus 3, minus 366, could tell me something. Yeah, I already looked at this. 1025, so it's kind of maybe a little bit high. And 1031, kind of not even very high. Um, what's the histogram of this guy look like? Number of bins, 14. So the high outliers don't have short, high outliers don't have short trips, short duration. So only uh, except for this one, which is number 23, except for that one, well, I guess 3, 4. Okay, so on the nobody has, one person has a, that's kind of interesting. The outliers, okay, all right. The outliers have a different distribution of okay, 4 up to 14 duration, outlier occurrences equals sum if at these guys based on days equals Oh, some range. Oh, range, uh, range, okay, all right. A, some range. Okay, 0. Number of, so if I add all these, it should be the number of rows I have, 46. Yeah, 46 rows. Okay, so then if I do total accountive uh, this range equals 0. What? There are no 1 or 2 day trips? Of course there are. Oh, huh. Okay. And then this sum is 1,000, which is the total number of rows. Okay. So now if I plot these two, outliers are much more common, 13 and 14 and 8-day trips. So outlier odds. Seven, 8, 13, 14. 10% chance, 10 to 15% chance, 10, 11. It's almost like a 7, 8, 13, 14. Okay. So outlier, what about outlier direction? Well, hold on. If I did error versus duration, it should show me, okay. Now, there's not a lot of data, but like for instance, if 7 and 8 were always high and 13, 14 were always low, it would show up here. There's a lot more. 7, 8, 13, 14. Well, it looks like 7 is not as bad as, again, I can't, it's hard to start seeing phantoms. What's that? Oh, 7, 13. 7 and 8 have the thing is I can't. Okay, so let's see. let's see if I do. Okay, let me sort by duration, and then maybe edge case. No, maybe edge case then duration. Okay, 14. No. Okay, maybe I can just sort these. So 7 and 8 have a lot, and 13, 14 have a lot. So this is my dummy copy. Can I delete? What if I delete these guys? And then see under what conditions. Oops. No. This is. I don't think this is. Yeah. Okay. So I'll go back to my. Squeeze this down a little. Okay. Error versus miles. See, this is what I already did for each day individually. Error versus miles, but then I screen for, let's say we're only looking for days 7, 8, 13, 14. Oops. Okay. Lots of minus 250 up to plus 250. Now if I look at everything except 7, 8, 13, 14. So there is a difference in distribution. So if I were to do a histogram of error, let's say I do a number of bins 5. Okay. There's a few outliers on the low end. Okay. Now if I switch this to, let me do trip 7, 8, 13, 14. If or that equals 7, A2 equals 8, A2 equals 13, A2 equals 14, 1, 0. Okay. Clear filter. Oops. One, 0. What the heck? 0, 1. The x-axis is moving, so I can't really. No one has 0 yet. Yeah. 40 minutes left. Uh, and it total receipts amount. Ooh. Oh, no, no. That's um, nothing below 500. Holy shit. For two. Okay, I'm gonna. Holy crap. Okay, I also want to see the error. Because the expected output, can I show expected output versus error? Also, expected out, this has to go, it's not useful. It has to go expected output versus error. Okay, for 1 day, 2, 3, 4. Okay, I need to fix these axes because okay, clear filter. All right, so I'm gonna format axis minus 410 to positive 300. This is going to go 0 units. Okay, and then okay. So now when I change the conditions, I can actually do a. Okay, 1, 2, 3, It's interesting. It's going high and low, but our error is not high and low. It's just the data falls into 4. Okay, 5, 6, 7, 8, 8. But I have rules for 7 and 8, right? 7. No, I only have 7. Okay, but anyway, 8, 9. It's like for each one, I need to predict. Well, so the errors are so the outputs are higher, never below 500, but the errors are not. So higher errors on those days. Hmm. Well, I think I'm stumped. So I'm going to submit now. It's kind of close to the end. I don't think I'm the odds. Yeah, odds are not good that I'm going to get any more breakthroughs. So let's see. So I need to run. Um, I need to run generate results. So I'll run eval again, just to make sure I haven't broken something without realizing. I should get 7076. Like I said, I'm expecting 600 higher, so that's 7600. Um, yeah, I'm out of idea. Yeah, I'm out of ideas. Well, I'm out of time. If you wait long enough, you can maybe think of something. But 7076. Okay, so we will generate results. So 7600 is maybe, or 76, maybe 7700 would be the estimate. If it's less than 8,000, I'll probably be happy. Well, I mean, it doesn't really matter. um, Okay, private results. Check private results.txt. It should contain one value per line. Lines with error indicate your script failed. Okay, looks okay. Submit when ready. Okay, I guess I will. I guess we'll go. Final result. We will commit, and we will push. Okay, then let's go to. Where am I? Nope. Okay, so over here. 10 commits. Latest is got private results. Okay, so back to where's the where's GitHub link. GitHub shows how to commit, right? How to submit. I mean, submission form. Duh. Okay. GitHub repo. Challenge. What's your score on eval? 7076. Upload the file. Private results, 7:30 p.m. Yep. Okay. LinkedIn profile. Shoot. Okay. Got team viewer. This is stupid. Yeah. Okay. Okay. Let's see. Required. Updated. Okay. All right. Well, I guess that'll do it. I can. Yeah. I guess that'll do it. I guess see how things shake out. Uh, Final. Let's see. Where's my posts? Um, let's see. Where am I? right, so I'm okay. Well, I guess we're June. Uh, yeah. So wait, maybe even yeah. These are all gonna these are all gonna change when stuff closes. Ooh, oh wow, a bunch of people got got a little below. Bunch of people got below 8,000. So yeah, most likely not in the top 10, but that's not too surprising. There's got to be some secret that's maybe there's a bunch of secrets. No, wait a minute. What happened to SRX9? 6467. Hmm. Okay. Well, anyway, um, it was fun. uh, it was fun. So anyway, thanks guys for am I giving up? Yes, I am giving up. Well, I'm sort of out of time because there's only 30 minutes left. I don't think that I wanted to leave a little margin in case I didn't want to fumble right at the finish line. So I don't want to work up until the, last, 5 minutes. And I'm sort of seeing diminishing returns. I mean, I might keep working at it. Well, am I? It's chances are not zero, but the chances are low that I would keep working on it. But we'll see. Maybe I get inspired and I could try, keep trying to lower the score. Um, but we'll see. I don't know. Probably not. But I think I'm going to end the stream here. Um, so anyway, thanks guys for hanging out with me, I guess. And do you think it can solve completely? I, I don't think zero is well. Reaching zero would be a different type of strategy, like generate a bunch of random programs, uh, like some kind of program search, I think is what I would try to do. Um, run random programs but make sure the programs are short so that you don't overfit to, because I could write 1,000 line program that would get it right 100%. But to do something a little more elegant and um, would be an interesting challenge. I think that's probably the only way to get 1,000. The only way to get a score of zero would be to do that type of thing. I think the regular, fitting machine learning kind of optimization, regression um, type of stuff which is basically what I've been doing, is not, wouldn't get there. Maybe it could get lower if I discovered the reason for the occasional outlier and had a condition for that. Then I could, detect those, apply a second rule, maybe get down lower, but not down to zero. So anyway, I guess we'll end the stream here. So thanks for hanging out, and I'll catch you later. Current score is 7076 on the eval. On the private set, don't know, but I'm expecting less than 8,000, maybe 7,700 or so. So anyway, that's my prediction for the final score. Yeah, I'll see you guys.